Hello,
everybody.
Miami. How's everyone doing?
Welcome to Miami.
Yes.
How's everybody doing?
And in case you forgot where we are, there is a queue in my jersey. So we're bringing AI Engineer to Miami today, and I'm so grateful to see. I can't really see that well because the light is so bright, but I can kind of see your faces, and I'm just so glad that you're all here to celebrate AI Engineer and accelerating practical AI applications. So I hope that you're as excited as we are about today. So my name is Ethel. I am one of the MCs for today. I am an AI researcher at Google, and I'm here with Iman, my colleague and dear friend.
Hello, I'm Iman, AI research engineer at Google, and I'm coming all the way from the San Francisco Bay Area, West Coast. By the way, who here is from the West Coast? Raise your hand if you're... All right.
Nice, we see some hands.
I see a few hands.
Yeah.
Who's from the East Coast?
Oh, wow.
That's not fair. We're in the minority here.
Well, Miami is East Coast as well, so.
Yeah, I can imagine. So who's from the central U.S.?
Yeah, we see some
Okay,
hands.
okay, that's a good woo. And who's coming from outside of U.S.?
Nice. Wow.
You see,
Thank you for traveling.
Pretty diverse. And I'm curious, raise your hand if by this time next year, you're going to be replaced by AI. I'm counting around 20 colleagues with realistic expectations. Well, that may be true, or maybe the reality is AI will expand what's possible for us, and it's going to multiply us, and it's going to redefine what's achievable. But before that, let's hear some stats about who's attending.
Yeah, so we want this conference to be about you and your connections. So sitting with us, we have people from 23 countries. So thank you all who are traveling internationally and also locally, including me myself. We walked down a couple of flights to come here. But no matter how far you traveled, we're really grateful that you're here. And we also have some companies that are very excited about sending some engineers over. So we have 2 companies that sent 12 engineers to the event. So thank you so much for doing that. Also want to do a quick roll call. Who in the audience is an AI engineer? Nice, we see some hands. What about quality engineers? PMs? AI researchers? Okay, so an overwhelming group of AI engineers. So you're in the right place, and we're so happy to have you with us. And we have great talks. We have our sponsors in the expo area for later, and we really want you to be able to network with each other, talk to each other, and really just build a community here. So that's the vision that we have for today, right?
Big plus. Yeah, last night at the opening reception, I got to talk to people. Some told me about their personal experience. Their friend got sick. They want to leverage AI to help them and improve their life. Or talking about how they want to leverage AI to bring education to some parts of the world that don't have proper education. Very personal stories, and I'd love to hear that. And I think that's the core of the idea here. Let's consider this a playground for amazing minds to come together and build connections and make big changes in the world. And I think that's part of the vision. And who's better to tell about the vision more than the amazing Gabe Greenberg, who is the CEO and founder of G2I. I would like to invite Gabe to the stage to share a few thoughts. Thank you all.
Welcome, Gabe.
AI Engineer Miami, what's up? How we doing? All right, I like it. I got through my start. I said AI Engineer Miami rather than React Miami, so I'm starting off well. It's our next conference, okay. All right, well, I wanted to give you all a little bit of an origin story because this conference and this series of conferences is pretty unique. It's special. There's a really special group of people that you're sitting with right now. Dax is special. The speakers, I have a lot of love for the people in this room. I'm the founder of G2I. You can check us out at g2i.ai. We're focused on reinforcement learning environments in the human data space, specifically around software engineering. I'm also the co-organizer of this conference, at least AIE Miami. and React Miami, and you can find me on Twitter. I'm not going to call it the other name. Twitter/Gabe Greenberg. You can follow me there. So, origin story of how this conference started. I flew out to San Francisco. I knew nobody, and I walked into ReactConf 2016. And the first person I meet is Ryan Florence. Some of you may know him in this room. And a little bit of a celebrity MooTools background, and I shake his hand, meet him, cool guy, answered a few questions, and I sit down next to him, and he opens up his laptop, and on his lock screen is, wait for it, Brad Pitt. And I knew that I was instantly in the right place. This guy does not take himself too seriously. Nick Schrock was up there talking about GraphQL. React Native was kind of new. It was just beautiful, this bustling. We were all excited, on the bleeding edge. And I got really involved in the React ecosystem. We served for Reactiflux at a lot of Q&As with the React core team. And a few years later, I got really, really, really sick. I had mold toxicity and mercury poisoning, and I would sleep on the floor underneath my desk for hours because I had migraines. I couldn't think straight. I couldn't do simple math at times. And I would get up and do a little work and go back to sleep. There was times I'd go into treatment on Monday and I couldn't work till Friday. And this was years. This lasted for 8 years of my life. It was the most terrible time. My kids, didn't see me much. My wife was kind of like, what's going on? And finally, I was diagnosed. It took me so many years to get diagnosed with the mold toxicity. And I'm sitting there on a vacation in pain, physical pain every single day. And my wife and I go, we need help. We need to raise money to get you help. And so I put it on Twitter, and I had been involved in the software ecosystem for a while at this point. And this tweet changed my life. Dan Abramov on the React team said, let's help Gabe. And they raised $22,000 for me. And I got healthy a couple of years ago, and I've been healthy since from this. Yeah. So a couple years later, I'm up too late on Twitter, of course, and I post this. Someone should put on ReactConf in Miami who would be interested. I own the domain and hundreds of other domains I've never used. And of course, Ken Wheeler says I'd go and probably never be invited back. He was invited, and he was invited back, believe it or not. He'll be here this year. And Michelle over there and her sister Becca said, yes, we're in, and they were the ones that convinced me. Michelle was the one that convinced me this could be done with no money right out of COVID. And so we felt called to it. And this was a response to what you all had done for me, the organization, G2I. We felt called to this conference and to serve the people here, to not make it a quote-unquote corporate event for the profit, but to make it really for the people. And of course, Swix, you can see him down there at the end. He's come almost every year to React Miami, spoke many times. And so he created AI Engineer quite a few years ago at this point, runs Latent Space, is super involved. He's at Cognition. And he said, Gabe, Michelle, Becca, can you do the first AIE in America? So here we are. AIE Miami is born. Thank you all so much for coming. It means the world to us. And there's one more thing. Our company, we've worked with the Frontier Labs for a number of years now. We've had to move really fast, build production software at, in matters of just compressed timelines, like I think some of you all would believe because you know. And so today we are announcing Orchestrator AI. It's a multi-agent orchestration platform for complex engineering. You can check it out at orc.ai. We are really excited about this. It's been dog-fooded. You can run many different agents in the platform. The coordinator runs the implementer, auditor, reviewer, validator, researcher. These are only some of the roles that we have in the platform. Comes with a confidence score, shares the known issues, the assumptions, of course, that the different agents are making. And you can spin up to 16 of these for a single task. There's true adversarial governance with this. And we're able to catch a ton of large language model drift, extremely fast interagent comms, and of course, model agnostic. It comes with a self-pruning context memory that reduces context bloat, and then also the meta observer in the platform automatically adds new skills as it identifies opportunities for them, and then an observability layer that allows you to delete them or add new skills manually. So we're really, really excited about this. We're signing up design partners. We've been doing a little bit of benchmarking, and then I'll turn it over to Dax to come talk about OpenCode. We do a lot of spec-driven back-end work. We need to do it really fast, and our engineers were dogfooding this platform. Really, it's been a couple of years in the making, behind the scenes, and they've been building these spec-driven APIs. So if we look at the pet store API that we did, you're looking at 100% path coverage and 100% semantic score around the quality, the response shapes, types, and behaviors matching the spec. And compared to a single agent harness like Claude Code, I mean, it's about the same. You know, we're 6% better, not much of a difference. Now, as we increase the complexity going into a startup API, we're able to see the lift. You know, we're able to hit 100% path coverage and 100% semantic score when Claude Code is hitting 78% and 60%. Interesting. But then we really increase the surface area of this thing and the complexity, like 8x on the spec of what a startup API would look like. And we're seeing the lift where a single agent harness might hit 22%. We were hitting 92% on the semantic score, and the path coverage is 100% for us. So excited in half the time to launch this. And lastly, we spent the last 72 hours making sure we could have one more benchmark. We actually rented a hotel room to put this laptop in just to run the benchmarks because the Wi-Fi was not so good in this hotel. Which is a funny story. We ran the Orchestrator against SweBench Pro, specifically GPT 5.4 High. It's about 731 tasks. We bucketed it into very easy all the way to very hard. But these are really, at the end of the day, easy is not super simple. You're talking about a multi-file fix and subsystem logic understanding. So we're seeing bucket by bucket, really, the easy, medium, and hard are 17.1% lift over GPT 5.4 High, 14.8% lift, and then a 1.7% lift on hard. And when we get to very hard, we're talking about complex, long horizon issues spanning multiple days, a 5.7% lift. So 8.4% overall on top of the model. To give you an idea, I think GPT-2, 5.2 to 5.4 was a 4% lift, and Opus 4.5 to 4.7 was a 7-point lift. So we're excited about this. This is able to execute SweBench Pro above Opus 4.7 with GPT 5.4. And if you'd like to sign up as a design partner over the summer, we'd love to work with you and build with you. So thanks for your time. Enjoy Dax and enjoy AI Engineer Miami. Thank you.
Am I going up right away or are you?
Thank you so much, Gabe. Our first presenter has tried his hardest to insult us all by his choice of the title. He is a world-renowned troll on Twitter. That's not me, that's Becca said that. And the title for his talk is, "You Don't Have Any Good Ideas." I would like to invite Dax Raad to the stage. I don't know where he's going with this, but I'm going to let him figure it out. So please welcome to the stage.
All right. I don't have any slides, so I'm just going to walk around and talk to you guys. A lot of people in here today. All of you came from all over the world, all the way to Miami, but you're not like other people, because you came here to talk about AI. Not why people usually come to Miami. Kind of embarrassing. It's okay. There's a reason you're here. The reason you're here is there's a lot of smart people that are going to be here giving talks. These are people that are at the top of their game using AI to build software. You're going to learn all the tips, all the tricks, give you the edge, do things that used to take a week, do it in a day, You're going to go home. You're going to use these tricks. You're going to build all of your ideas. You're going to be super successful. You're going to be rich. You're going to fix everything that's wrong with you. Your mom's going to be proud of you. There's only one problem, which is you don't actually have any good ideas. And that probably hurts to hear, but it's true. It's OK. I don't have any good ideas either. And I think this is the first time that we're all having to confront this fact. We have more capability to build stuff than ever. And you think, oh, finally, we can kind of ship all the stuff that we always said we would. And it turns out a lot of the stuff that we thought was good ideas are not good ideas. And this is the number one problem that I'm struggling with, my company's struggling with. Yes, again, my name is Dax. I'm the co-founder of Anomaly. We make a decently popular coding agent called OpenCode. And this talk is going to be all about product restraint. So to understand what I mean by this, let's think back to before AI was a thing, before coding with AI was a thing. It was like a long time ago. This was like 2 years ago, forever. But if you think really hard, you can think back to that time and imagine what it was like. For those of you that are programmers, imagine working at your companies. Someone would come to you with a new idea, with a problem, with a feature they wanted to ship, and it would be really annoying. You would hate it when someone did that because you had a huge backlog of stuff you're already trying to do. You had all this stuff that you wish you were doing better that you don't have time to get to. So when someone came to you with yet another thing to put on your roadmap, you did what the lazy engineer does, and you pushed back on them. You argued every reason why we shouldn't do this thing, why we shouldn't ship this, why the company shouldn't be doing this, why the person was stupid. Maybe we should do this later. You basically were the obstacle to getting anything done, just because you were overwhelmed and you pushed back a lot. And rightfully so, the company hated you for it. If you look at most companies, you talk to them, you talk to them honestly, most parts of the organization hate the engineering team. And for good reason, because every problem that they have is blocked by engineering. When a customer yells at someone on support, it's because the engineering team hasn't shipped something that would have fixed their issue. When the sales team loses a lead to a competitor, it's because the engineering team has, they have a feature they haven't shipped. The competitor does. So it's just, engineering has just been the annoying part of the organization forever, the source of every single problem. At least the way it feels. And it feels kind of stupid because software is virtual. We're not like physically building things. We're not moving things from one place to another. It's just in this virtual space. And it feels like the moment we have an idea, it should just exist, right? Like it's just a thing in the app. Like why is there so many steps and processes in between that? And everyone wished that things could be different. The past couple of years, it feels like that's kind of changed. We've gotten the ability to kind of go from idea to a real-looking thing really quickly. And everyone's super hyped about this. Like every company is trying to adopt this workflow as much as possible, blow up every single process that they have. If you're not adopting this, your competitor's going to adopt this, and you're going to get left behind. We're like measuring tokens. You have token leaderboards, see which engineers can get to the top of the token leaderboard. If you're not spending 5 times your salary on tokens, you're going to get fired. So we're all going crazy with finally all this pent-up frustration that has been around for decades with slow engineering is solved, and we're like going crazy with it. And I'm not saying there's not a lot of positive from it. Like a lot has changed for the better. I work on an AI coding agent. Like I believe in this in a lot of ways, but it's not universally good. And I want to talk a little bit about things are so different now, and we look back at all this frustration, and I think what I'm realizing is that frustration was kind of saving us from ourselves. And to understand this, let's think about how things used to work, right? You had, typical organization, they had the product, engineering, and design roles. Because engineering was so backlogged all the time, product and design would work together and refine ideas before they brought it to engineering. It was a lot cheaper back then, 2 years ago, to have a mock-up in Figma than it was to build like a working prototype. So a lot of ideas would just die at this phase. Someone would have an idea, they would kind of have to go work with design, they'd think through it. They might realize, okay, this actually didn't make any sense. Or we have to refine it, and the initial idea turns into something totally different. And by the time it kind of bounces through the organization, a lot of the ideas die, or they get refined into something into something pretty decent. Or they get shelved and kind of brought out later. And that was like a natural thing that was happening. There was all this filtering that was going on. Now, things are a little bit different. Anyone in your organization can kind of ship an MVP. They can prompt a coding agent, spend an hour with it, and implement a feature that they think is good. And this seems obviously good, like why would anyone be against being able to experiment and build stuff and iterate and try things? Obviously, it sounds like a good thing. But the sneaky thing about MVPs is they look almost done. You spend an hour, build something, and it basically looks like it's there. At that point, there's momentum behind it. The moment something kind of looks like it's basically there, it has a life of its own. At that point, it's inappropriate to really think about it from first principles or question the whole premise of it. It's basically already there. People around you aren't going to really be a roadblock or get in the way. And it ends up in the product. These ideas, they go from someone having the idea to prompting it. They spend an hour on it. It's barely any work. And then it's in the product the next week. And we're told this is actually a good thing. We're told that in the new era of AI, it's all about you have a problem, you solve it right away. You ship the fix right away. The faster you go, the better. Go fast, 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 fast. That's kind of the vibe of everything. And so that adds to it even more, right? We're not questioning anything that we're doing. And so unsurprisingly, this creates bloat. Products end up super bloated. They end up with features that are in weird spots. They end up with 3 different ways to do things. And it's kind of making me realize that without the previous checks and balances of just things going slow, we just didn't have a lot of good ideas. Most of the stuff that we're shipping, they're bad ideas. I look at our own products, and the products we work on right now have been out for less than a year. And I look at it, and I'm like, what are all these features? When do these get in here? We should never ship this. We should never ship that. But it's just gotten so easy that things just slip through into the product without anyone really thinking twice. And this is kind of messing up the whole team dynamics as well. For the first time ever, design is behind engineering. Stuff just gets shipped, right? Stuff just gets shipped out there before design has even looked at it. So now they just have a huge backlog of 100 features that are shipped that they need to go one by one and polish. And just independently going one by one, polishing 100 different features, that doesn't add up to a good product. They're not doing their role, which is to think cohesively about a product, think about the experience end to end to create a proper universal experience. There's kind of one-off reacting to the stuff that's going out. This is changing the engineering side as well. Historically, if someone came to you and wanted to build a new feature or iterate on a feature on a system that already exists, you would look at this system and you would think, okay, this feature doesn't really fit into this system, so we'll have to rethink this system from scratch, which is going to be a lot of work. We have to redesign it to support this thing. Of course, there's always hacks, but you have to pay the cost of that hack. You have to be the one to go and hack this thing into the system. Anytime that hack later rubbed up against other things incorrectly, because it interacts with every other feature you had to deal with the pain of that. You no longer have to deal with the pain of that. You can go tell your agent, hey, do the bullshit for me, and you don't have to deal with the dirty work really. So the engineers' willingness to ship hacky solutions, we're just a lot more willing to do that. Our bar for what we're willing to do to our code bases is on the floor at this point, because we're not paying the price for the cost of it. And that really shouldn't be the case, right? Just because you can offload the pain to someone else, in this case, it's not a real person, or well, some people think it's a real person, but that doesn't mean that we should change our philosophy on what we're doing or how we're doing things necessarily. So that's also impacting the engineering team as well. And of course, we've had the historical excuse, which is, it's okay to ship hacks sometimes. You make the judgment call on it's better to get something out now and deal with it later. You have an excuse, we'll get back to it later. You intend for that to be 3 months. It ends up being 3 years. And by the time you get to it, you totally regret having done it in the first place. We've got whole new excuses now, right? It's okay if this is bad. The agent will fix it later. It's okay if this sucks. The models will get better, and it'll just kind of solve it. It's a completely, it's a faith-based approach to it. Just magically, it's going to get fixed in the future. Which, of course, it doesn't. It really doesn't happen. And the net result of all these changes is just a ton of rot. Our products are rotting so quickly, right? We look at, and I think we can all feel this in our own products and products that we're using lately. they just feel really old really fast. You know, you use something that came out less than a year ago, and all of a sudden it feels like it's already 5 years old, like post-private equity acquisition, like institutification. This is happening in like several months. And again, it comes back to the root problem. We don't have a lot of good ideas. When we just ship things unchecked, we just speed run that life cycle of product deterioration. And it's like happening at crazy speeds these days. So the key issue here is restraint. We have more power and capability than ever, which means it just magnifies our judgment. So we need to exercise a lot more restraint. And I don't have a lot of good ideas on how. I think for me, I just look back to what traditionally has made sense and try to really keep that in mind. So, you know, when someone comes to you with a problem or a user has a problem, if you just like react to that and fix that problem right away, you're just going to make 10 different solutions for 10 different problems. If you slow down and wait, you listen to this problem, you listen to that problem, you might realize, hey, these 10 problems they seem unrelated, but they actually are related. If we ship this one thing, it'll fix not only those 10 problems, but also the 50 other problems that no one's even brought up yet. That's actually your job when you build product, right? Your job isn't just to be like a prompt router to go from the user complaining to routing to the agent. You have to slow down, think, and absorb, and really make the call on what you're actually shipping. So that's very important. You know, slow down, absorb, and try to ship high leverage things that actually solve a lot of problems. The other thing is, I think a lot about the onboarding cycle. Every product basically has one good idea in it. And your job is to get the user from not knowing about your product to understanding that one good idea as fast as possible. All the other stuff that you come up with, they're important and may be useful, but they're secondary ideas. So they're not going to go into like the main onboarding. A lot of companies mess this up. I think we've all had the experience where you open up a product and there's like a dozen different directions you can go through. And the people working on that product are like, oh, we're giving them so many options. They're going to go like play around with this and try all this stuff. People don't do that. They just give up and they leave. So you're never going to you shouldn't mess up that one flow of getting to your good idea, which means that every new idea you think of, you need to craft the path of, okay, they're a user and they're kind of using my product. How do I take them from there to the point where they understand this new feature? How do they learn about it? How do they discover it? How do they know when to use it? How do they know how it works? It's really hard to come up with this stuff. I have had so many great features that I'm like, this is an awesome feature. I love it. It's so useful. But I wasn't able to find a way to get a lot of people to actually discover it. And so we don't ship it, right? We don't ship features like that. And it's painful. But again, it's restraint. You don't want to put stuff in there that has no actual way of being used. So I think if you keep these in mind, you naturally don't ship as much stuff. Right now you're having an idea every single day, but if you apply these filters, most of them don't really pass. You're not going to have a good idea every day. You're not going to have a good idea every week. If you have one every couple months, I think you're doing pretty well, and that's like a good cadence to aim for. Regardless of how fast AI is letting you go, there's no reason why you suddenly have 10x the number of good ideas, right? So a couple of good ideas a month, I think you're doing pretty good. And to close off here, so I think, again, thinking back to the frustration everyone's felt in the past, I think we can now kind of look back and feel a little grateful for it because it basically was, again, like I said, saving us from ourselves. We were moving a lot slower. It was filtering out a lot of bad ideas on its own, and we never had to confront the fact that most of the ideas were bad just because they were kind of naturally being taken care of. And as we kind of enter this new era where that process is going away, we have to be a bit more aware and be intentional that, hey, most of our ideas are not good, and that's okay. That's exactly how things are supposed to be. All right, that's all I had. Thank you, everyone.
All right, give it up to Dex. And then just to confuse you, the next one is Dex. So Dex needs no introduction. Actually, a lot of people know him because he's a veteran of AI engineer. So if you have watched some of his talks, one of them is very famous. It's called No Vibes Allowed. But I'm still going to give a little introduction of Dexter for people who do not know him. So Dexter is the founder of HumanLayer, and I actually had the honor to meet Dax in San Francisco, which is where he's based. So Dax has always been a prominent figure in the AI community, and I'm really glad that he is here with us today. So today he's gonna tell us everything we got wrong about RPI. So tell us more, Dax.
Amazing. Thank you, Ethel.
Thank you.
And thanks, Dax, for that wonderful intro. And sorry, she said, give it up for Dax, and I literally thought she was saying, give it up for Dex. So I made the mistake I was about to make fun of all of you for, which is praising me on Twitter for all my hard work on the OpenCode project. That's the other guy. I have been doing coding agents for a while, though. I think the No Vibes Allowed is almost up to, I wanted it to get to 500K. But anyways, we've done a lot of talks. I'll start with this guy, Igor. I'm not going to go deep on this, but it was basically like, hey, when you use AI, you ship a lot more, but a lot of it is fixing the slop you shipped last week, and it doesn't really work for brownfield code bases. And what we want to do is we want to solve hard problems in complex code bases. We had to figure some stuff out. We posted our methodology on Hacker News back in September, and it was on the top front page all day. There's probably about 10,000 people who have gone and grabbed our open source prompts. I found public evidence that RPI is in use at companies like Uber and Block, and private evidence of a bunch more that I can't talk about, which sets us up for a great talk about RPI and why it's so great. But we're not going to do that. We're going to do a different talk. I'm going to tell you everything we got wrong about RPI, because we thought we had this thing figured out, and of course, models change really fast, and this whole world is changing. Every 3 weeks, there's a new thing. And I think we got a couple things wrong. Standing by. All right, we're back. We got a couple things wrong. One of the things was we said it's okay to not read the code. We advised people to read very long plan files, and we said Claude can have a little slop. Well, we never said this. It was implied, though. It was, let the model cook, and we'll be fine. And so, and you all have been doing your homework, and I think at AI Engineer Europe, we kind of figured this out. There's this continuum now, the Zechner-Lapopolo continuum. I'm going to tell you how we ended up all the way over here, despite 6 months ago, 8 months ago, being all the way on the other side of the spectrum. But first to recap, and I can't see many of you, so you have to raise your hands very high. Who's run this prompt? Who's done research code base? I'm going to assume everybody. It is very bright here. What about create plan? Raise your hand if you use this prompt. Leave your hand up if you use it like this. Hey, we got to go ship a feature for this thing. Leave your hand up if you ran it like this. Work back and forth with me, starting with your open questions and outline before writing the plan. Interesting. Some of you found the magic words. That's great, but also it's a problem. Since October, we've worked with thousands of engineers of companies of all sizes and trying to help people use coding agents to solve hard problems in complex code bases. And we found over and over again, we would give the tools to an expert, and they would get great results, and then they would give it to their team, and the results were not always so good. So we got in the trenches with our users, as product-minded people do, and we went to go figure out what was going wrong. And we found 3 things. The first one was that people were getting bad research. And if you recall from No Vibes Allowed, this is the one slide I'm repurposing. But you would pick a zone of your code base. You would say, hey, go look over here. And you would send off a bunch of subagents, take these deep vertical slices through your mini repo code base. And then you would compress all of this down of, like, how does all this work into a single document that is just like a snapshot of the parts of the code base that matter for the task that we're about to go embark on. And we said we should keep this objective, right? Discourage opinions, avoid implementation planning. Research is really just the compression of the truth about the code base and how it works today. And really good engineers we noticed this pattern where people would take the ticket and they would turn it into questions, and then they would pass the questions into the research. So if the thing you're building is, oh, we need to add a new endpoint to reticulate splines across tenants, you might ask questions about how endpoints are registered, what touches splines, and the worker program that handles reticulation. But a lot of people would just be lazy and say, I got to do this thing, go research the code base for me. And this was a problem because if you tell the model what you're working on, good research is mostly facts. But a bad research will have opinions. And these models are so deeply trained to go solve our problem that it's going to steer the research towards its thoughts on the first thing it picked as the right way to solve this problem. We'll get more on why models shouldn't have opinions. They do get to have opinions, but just not at this part of the workflow. It comes back to this idea of, do not outsource the thinking. We also saw people were getting bad plans. And this is a really interesting one. Hopefully you get some takeaways on things you can apply to your own prompting. But we had this single prompt with 85 instructions in it. And basically, if it worked properly, what you would get is a laggy YouTube video. All right, one more time. You know what? This is why we have backup slides. It would look like this. The model would go back and forth and ask you a bunch of questions, and then it would walk through and like ask you what order you wanted to do the things in and how you wanted to test them. And only then, after this long conversation where you'd built up all this shared understanding of the problem, would it write the plan. The problem is that if you were in a hurry and you didn't prompt it quite right, it would just spit out a plan. It wouldn't ask you any questions. It wouldn't put you in the loop. You were just getting whatever the model decided was the first way to solve this problem. And that's basically the same as just prompting it to go do the thing at that point. And so we gave the tools to an expert, and they got great results, and some other people didn't. And we were like, what was the difference? And this was an embarrassing thing to say in like customer onboarding. But you have to say the magic words, apparently, was the challenge. If you didn't say this thing, I mean, if you've been prompting LLMs for a while, you know, hey, you repeat the most important instruction at the very end of the prompt and at the beginning. So we said, work back and forth with me, starting with your open questions and outline before writing the plan, and then it would follow the process. But if you didn't do this, 50% of the time, it would just skip that. And this was not the user's fault. Like, if you build a tool that requires hours of training, like, go fix the tool. And so we dug in, and we're like, why are these steps getting skipped sometimes? And the basic takeaway here for whatever AI thing you're building, whether it's coding agents or something else, is you have an instruction budget. My co-founder Kyle is here somewhere. He wrote a really good blog post about like how to like tune and optimize your Claude MD. And the big takeaway was like frontier LLMs could really follow about 150 to 200 instructions before they really are just kind of half attending to all of them. And obviously this was a year ago, so inflate that number a little bit, but there is a budget. And so this prompt is 85 instructions, plus your Claude MD, plus your system prompt, plus your tools, plus your MCP. It's very unlikely to get great adherence. I'll talk about how we fix this. The other thing that we kind of recommended and did was plan reviews. We advocated. We said, look, if you're not going to read the code, you got to read the plans. This is me on stage saying, in November, you have to read the plan. Some folks even code reviewed them. They would get together on their team and read the plan. But a 1,000-line plan was about 1,000 lines of code. It's like order of magnitude. It would be about the same amount of reading either way. And plans can have surprises. And so you'd actually end up reading the plan, and then someone would go implement it, and then you'd have to read the code again. You're actually doing more work, not less work. Because, you know, 1,000-line plan, 1,000 lines of code, et cetera. That's not leverage. That's actually doing more work. So the new advice is don't read the plans. Just read the code. Right? Yeah, I know. I am humble enough to admit when I was wrong. Here we are. This is all a journey. Don't forget to learn. There are other ways to get leverage, though. There are other ways to get more out of less, and we'll talk about that. But this is how we ended up all the way on this side of the Mario side of the continuum. And again, yes, you could say, hey, Dex, you know, in August you said don't read the code. Yes, we used to be all the way over here. I am humble enough to admit when I was wrong. These things change. Please read the code. We tried not reading the code for like 6 months. It did not end well. We ended up having to rip and replace huge parts of that system. And all of you now who are just finding out about the, like, oh, we can do the lights off software factory thing, and we just won't read the code. I'm like, all right, be careful. If you have people who depend on your code, if someone's going to get paged at 3 in the morning if something is broken, please, I'm begging you, please read it. There's an entire profession here on the line, and we need to save it. This is why I'm kind of like iffy on the agent swarms thing, because like the bottleneck is, last year it was like, how can you spend as many tokens as possible? And this year it's going to be like, okay, how do you actually, what's the right speed you can go? Because if you go 10x faster, but you're going to throw everything away in 6 months, that's not actually like productivity. That's actually just burning time and money and your employer's time and your time. I do think you can get to 2 to 3x and still read every line of code and own it and have good architecture. As Mario would say, I'm not going to say it so we don't get demonetized, but everyone is racing to build these lights off like slop factories, right? And I think, again, what's going to happen is you're going to wake up one day and there's no one's read the code in 3 months, and you have a bug that the agent can't solve. And then you're going to have 3 weeks of downtime as you re-onboard everybody on your team back into your code base that they haven't read in 3 months. And in that 3 weeks, you lose all your customers, and now your company is dead. It's not going to happen to everybody. It's probably going to happen to somebody. Be careful. So we're going to try to token smarter, not harder. And we do that with a couple different ways. The research is the least exciting one of it, but basically, take your ticket, turn it into questions, you make the research. We can just do this with prompting and workflows. So we basically hide the ticket from the researcher programmatically. You have one context window to generate questions, and then you just feed those questions in to generate the research. This can be done trivially with AI, sort of query. If you build deep research, this technology has been around for a while. We also have to get better plans. And like before I was the coding agents guy, I was the context engineering guy. And we talked a lot about, don't quite use tools in a loop all the time. And there was two reads of context engineering. One was like, put better information in the context window. This is the most common one. Anyone here the RAG pipeline? To be honest, come on. I actually can't see any hands. I assume some of you are just lazy and not wanting to raise your hands. It's also about getting better instructions in your context window. And of course, Jeff is here and he's talking later. And I used to have to explain who Jeff was. Very exciting now that everyone knows who Jeff is. But he talked about, the more you use the context window, the worse results you get. We talked about the dumb zone. We're over about 100,000 tokens for that's a Claude model number. The GPT number is different. Basically, you're not just giving the model too much information. You're probably also giving it too many instructions. And so an example, like very simple, is like you're building a customer support bot, and you use prompts for control flow. You say, okay, if the input is this, do this. If the input is a product feedback, do this. If it's a billing issue, do this. Give it a whole bunch of tools and say, hey, go do the thing. This probably works, but as it gets bigger, your performance and accuracy will probably go down. And what a lot of people end up building is they have an initial step to classify, and then they have smaller instruction modules for each of the different classification cases. And you build this workflow in this pipeline. And this will be like faster, more performant, more accurate. You could probably use a smaller, dumber model if you build your system this way. And so we took create plan as a single mega prompt, and it's supposed to look like this very specific guided workflow. And we split it across several prompts to design, structure, and planning. We're not going to talk about implementation today, but it's got these 3 different phases, each build on each one. And before it was 85, now they're all under 40 instructions. The lesson, don't use prompts for control flow if you can use control flow for control flow. Switch statements and if statements are actually kind of good. And this is not just for coding agents. This is for, you can imagine how this would apply in every single AI application you might build. And it was kind of funny because we got up on stage in June at AI Engineer, and we said, don't do full-fat agents, tools in a loop. No. That doesn't make these workflows, do these pipelines. And then by August, it was kind of like, ooh, with this Claude Code thing, that thing's pretty good. Tools in a loop might be back. And we turned around and we built these monolithic prompts of these giant complex workflows. And so I decided it was time to drink our own Kool-Aid and apply this stuff to how we were doing this. I hear a lot of times, hey Dex, won't this just get bitter lessoned? And I assume none of those people are here, but all of you who hang out on Twitter and say this to me, I want you to know that when you shout this at me on Twitter, this is the voice I assume that you're saying it in. This is what plays in my head. Because I think that, in my experience, the way this works is you got a given frontier model. It's got some sort of capacity at a variety of tasks. And through naive prompting, you get to do certain things. And then we come in and we do our context engineering, and we can make it better at certain tasks that are relevant to our problem. Then a new model comes along and makes most of that work irrelevant, better at most tasks. Maybe it's not as good at certain tasks. But then we do more context engineering, and we make it better at the next thing, at the next set of things. And we push the frontier. We're always going to be 1, 5, 10% past the frontier compared to the naive prompting. And this matters, because if you're doing long horizon agentic tasks, by turn 20, the difference between 99% and 97% is a 27% gap, because this compounds. Dan Schipper, I think, calls this like surfing the models, is like you can get better at using the new model faster than the new model can get better. Swix's take is right, the bitter lesson will kill this someday, but hey, it works for now, let's do it, and we do that over and over again until we get to AGI. So if you can get Opus Latest to do more to solve harder problems, or maybe you can get GPT OSS, which is small and cheap, to do the work of GPT-5 High, now you've captured something really interesting. So mind your instruction budget. And having more context, it's just more attention spread out over the same amount of, the same amount of attention spread out over more instructions is not going to fix this. And then we also found we got better leverage. So we split these things up to get better instruction following, but we also got more leverage. And so you can look at the structure outline. This is the plan that was built from that structure outline. It's less work for a human to review the first thing. And in general, these higher order documents are designed to be higher leverage in terms of human reads less, model uses less tokens, and we're talking at a higher level before we go down into the details. So the design discussion there is basically, where are we going? What does the final solution look like? It's got current state, desired end state, patterns default. What did the code-based patterns of the model find that are relevant to implementing this feature? What architecture patterns do we want to follow? Especially in legacy code bases, there's always 6 ways to do everything. And you find yourself being like, oh no, you found the bad pattern. No, we have to go do that one over there. This is your chance to do brain surgery on the agent before it actually goes and slops out a bunch of garbage. It'll track your resolve questions, your design questions. It's sort of like Claude Code plan mode, but written down to a markdown document. Matt Pocock pulled it out. This is the design concept Frederick Brooks had this idea of like this thing that is never written down, but is in everybody's head. So when you have this shared alignment with the model of what you're building, this is locked up in the context window. We put it in a 200-line markdown artifact. And this gives you alignment with the agent. And so you iterate on this thing. Again, do not outsource the thing. You want to give the agent every single opportunity to show you what it's thinking, to brain dump its entire understanding of the problem and what it thinks you want the solution to look like. And you say, OK, why do we need humans in the loop at this point? Basically, like, because you can't RL a model on architecture, because the cost function of bad architecture is measured in months and years, not in 5-minute unit test cycles. We also got better leverage on the structure outline. Design is where we're going. Structure is how we get there. If you want to map this to meetings that make engineers miserable, you have your design review, your architecture meeting, and then you have your sprint planning. So you take your design and all the previous stuff, and you build your outline. And it's just a high-level outline of what we're going to do and how we're going to check it along the way. And again, it means later reviews. You can read this and understand where we're going. We need humans in the loop here, too, as well, because somehow models just absolutely freaking love these horizontal plans. Which by that I mean, models, I'm sure you've seen this, models love to do the whole database layer, and then the services layer, and then the API layer, and then finally the front end. And before you know it, you're on the other end of 1,200 lines of code, and something is broken, and the surface of stuff you might have to debug is quite large, which means it's going to be hard for you, it's going to be hard for the model to figure out what's wrong. And so what we advocate for, and what when we use this stuff internally and we say our users, it's like build it the way you would have built it as an engineer. You don't write 1,200 lines code before you check it. You write a little bit of code and then you check something. Or a little bit of code, then you look at something. And then you wire your biz logic. And then you do your error handling. And so it's like this is your chance to re-steer the model. They're just markdown docs. You can ask for more detail, but they start super high level. So if you don't trust what the model's going to do in your high level doc, ask it to add more detail. And the way you get more leverage from the plan is you don't read it. It's for Claude. It's for the agent. You spot check it. You save the deep review for the actual code. But it does have the line-by-line changes. And it's not just about like human-to-agent alignment. It's also really powerful for human-to-human alignment. I think like before AI, it was very common for a 2 hours of coding feature to take 2 days because you have to plan and align with this is in like hundreds of engineers. You got to align with other teams. You got to do the planning. You got to do the code review. You got to rework it. You got to test it. And if you're just using AI for coding, then you will go faster, but you're not going to go 2x faster. You're not going to go 3x faster. But if you use the model to help you do planning and alignment with your team, then you're going to get better alignment because it's going to be more thorough. And then your code review is also going to be faster because everyone, it's basically like there is a thing that is not worth doing if you are writing it by hand into a Google Doc to share with your team, but is worth doing if AI can help you do it. And it really helps us compress code review cycles as well. I'm sorry I don't have an answer for you on testing and verification. Much has been said about this. That's for another talk. So if we want to put this all together, 5 phases to actually even just create the plan and then we go implement it. We call it questions, research, design, structure outline, plan, work tree, implement, pull request. Make a good acronym, so we just picked the ones we liked. This is QRSPI, crispy if you want. We found it's a really powerful way to get teams rowing in the same direction in terms of okay. So the things that we have to solve are okay, 3 steps was already a lot and took 7 hours of training. Now there's 7. I don't know if anyone else has built a crazy Claude Code / command system and then tried to teach it to somebody else and just stormed out because it was frustrating. We also have to know what's working and why. What is the impact of this stuff? And then we want to know if we want to make changes to our prompting system, how do we evaluate that? I have a whole other talk on how do you drive AI adoption in a large team where you need a process, and then as Igor would say, you need a defensible metric, and then you need somebody off in the corner who's shipping like crazy, and it's definitely not slop. And then you can kind of do this. But you can go do this. You can go try this in your team. There is no magic prompt. We actually don't publish the crispy prompts because the core of this is understand context engineering and instruction budgeting. And if you're not getting good results, break it down into smaller workflows. We actually leave the derivation of the prompts as an exercise for the reader. You should go get the open source ones from HumanLayer, and try to take the 3 prompts and break them up into 8. Try your own stuff. Come to your own conclusions. Like I said, this was me 10 minutes ago. We got in the trenches with our users. Be ready to spend hundreds of hours with watching people struggle to use your stuff. It is immensely frustrating and gratifying and my favorite part of the job. But if you're not up for this, consider whether you want to build your own prompting system. If you want to help with this problem, we're building an IDE for just collaborating on coding agent sessions. got all these opinions baked into it. We're open to design partners. We're hiring founding engineers. Send us a note, founders@humanlayer.dev. Keep learning, keep being wrong, keep adjusting your understanding of the meta. It's always changing. Thank you so much. Thanks, Dax, for the warm intro. Thank you, Miami, for welcoming us in. And I'm really excited to hang with you guys and the rest of the speakers and learn with you all this week. Cheers. Way to go get the
Thank
mic
you,
back,
Dexter. Okay, well, thank you for
Good luck
your
today.
attention. Okay, and before we introduce the panel coming up next, and we do see some chairs, they look very comfy. We're gonna thank our sponsors because without our sponsors, we won't be able to be here and gathering together. So I wanna thank Cold Rabbit, Cerebras, Mintlify, Sentry, Tailscale, and Cloudflare.
And
for
Modem,
sponsoring.
and the Appify, Auth0, Deepmind, Encrypt AI, and City Furniture.
So give it up to our sponsors for
Yeah.
bringing us together. And as we're setting up, Iman is going to introduce.
Okay, so where are we? Who's next? So far we had Dax, then Dex. Guess who's next? Max. Okay, Max is joining us from OpenAI, the folks behind ChatGPT. I tried to come up with some AI jokes for the conference. I tried ChatGPT. They weren't funny. So feel free to switch to Google Gemini. Yeah, unless Max can change our mind. Let's see how we can do. And instead of a talk, Max is going to surprise us with a panel talk. And this panel includes himself, of course, as well as Erik Thorelli, who's going to moderate the panel, Sunil Pai, and Ben Vinegar. Let's hear it for them.
Now? Ooh, okay, cool. How's everybody doing? We're gonna try to do a group selfie to start this thing off. Can we get the lights up? Yeah, okay. Awesome. Hey, hold on. Can everybody like stand up, stretch, get some energy? Yes. All right. Woo! AIE Miami! All right. Nice. Okay, cool. I'm going to post that, but instead of doing like 15 seconds of awkward silence while I post it, I'll just not listen to your guys' intros.
Thanks.
Is your mic on?
I think so.
Okay, cool. So my name's Erik. I work at CodeRabbit. I'm the head of DX at CodeRabbit, and that's all I'm going to say about me this whole talk, hopefully. I thought we could go around, introduce yourselves, maybe what you did in your career, who you are, what you did, and when you first learned that you have taste.
Oh, geez. How much time do I have? 30 seconds? Hi, I'm Max. I work at OpenAI now. I work on connectors across ChatGPT and Codex. If you've ever had ChatGPT and or Codex connect to anything other than itself, that's what I work on now. I'm probably most widely known for making styled components, which was a CSS and JS library that lots of people used back in the day that I think was widely renowned for its taste.
Hey, I'm Ben. If you know me, it's maybe because I worked at Sentry for a long time, worked on that product. I'm told it has pretty decent DX. I actually started as the JavaScript developer who was responsible for making that SDK work for the JavaScript community, so kind of worked from that perspective. And I don't know, people use it, so I think that's something.
Hi, my name is Sunil. I'm tech lead on the agent at Cloudflare. Spent some time on the React team, Oculus, spoken in React Miami, fun. I had a very boring real-time multiplayer infrastructure startup which had the best company name called PartyKit, so I have some taste. Bye-bye.
Okay, so taste is one of those things that everyone says they have. But I think we should define it. So maybe starting from the opposite end, what is taste?
So taste and imagination, I think, are two sides of the same coin. The first one is about focus and trying to remove the things that don't matter in terms of experience, in terms of storytelling, and so on. And imagination, I think, is about broadening it from a place of taste to expose yourself to everything that humanity is doing. So full of myself. I love that I get to answer this first. But yeah, I think it's about like focus and expansion.
I am not possibly smart enough to follow that up, so I'm just going to go over to Max.
I think taste is what we call opinions that make sense. That's really what it is. When people feel like an opinion makes sense and they can't quite put into words why, they just call it that person.
Okay, all those answers were boring. So can we get, what is bad taste? What does bad taste look like?
Opinions that don't make sense, Eric, obviously. Obviously.
Ben, are you going to?
What is bad taste? Man, you told me these were going to be kind of spicy, and I was not prepared for this. I got to punt again.
Very tasty.
What is bad taste? I think when people focus on the things that they just like as a person and try to generalize it to like everyone else, that comes off not very tasteful. This isn't a very JavaScript focused panel.
Okay, we can make it more AI here. So I'll save the more spicier questions around AI as follow up. Does taste scale with AI? And how can you make taste scale with AI?
I think one of the interesting experiences I've had about working with agents over the past, especially over the past 6 months, is that agents can solve lots of problems now, but they often solve them at the wrong layer. I don't know if you guys have noticed this. It's like you give it a problem, and you can solve that problem usually at the front-end level, or the back-end level, maybe the database level, whatever, right? Like there's lots of layers where you could solve a problem. And AI still today pretty reliably picks the wrong one, in my experience. And you end up with a solution that's like 3,000 lines of code that somebody has to review. That's like it kind of solves a problem, but also is kind of messy. And one of the hardest parts I found about working with agents, even still today, is teaching them how to solve the problems at the correct layers. And I actually think that's a lot about taste. It's about knowing and having the experience to know, oh, if we solve the problem at this layer, it's going to have these trade-offs and ramifications. If we solve it at a different layer, it's going to have different trade-offs and ramifications. And I feel like agents don't really have that today.
I'm going to answer this question. I'm going to answer the other one earlier. I'm slow. I need time. I think taste is maybe like a shortcut to assessing something's quality. I think that people who do not have taste need to look at things like metrics or box office numbers or number of downloads to say, oh, this is good, right? This is good because I see these statistics or whatever that is evidence that it's good. Whereas I think that somebody has taste can look at something and go, that's good, right? And then maybe over time that's validated in some way. Now, as it pertains to agents, and why I think taste is important in the age of agents is if you have that shortcut ability, if you can look at something, if you look at the output and you can quickly go, that's good, you could be way more effective in the age of agents, right? Agents can produce something, you can look at it, you can go, that's good. Somebody without taste, they might not find out that answer till way longer. And you could be way deeper into the hole of like how horrible this code has gone before, or the numbers don't make sense before you realize where you are. I don't know if that makes sense.
I fundamentally don't believe AI helps with taste. Well, LLM specifically, because so it's the idea that all ideas are spread out in latent space. So if you imagine it like a 2D map and you ask it a question, hey, I want to like solve this, make a UI. it starts honing in on particular areas. But stuff like taste are things that like span ideas across different parts of latent space. Oh, what if I took this popular art style and I applied it to this movie, so to speak? So I don't fundamentally think the exploration of latent space helps with forming taste. There's a really good book called Where Good Ideas Come From by Steven Johnson that goes into it. You should read this book, by the way. It's a very old book and it's
Agreed.
dope. Yeah, it's so nice.
I actually think I kind of disagree because I feel like it does help get more parts on the table. It does help explore the space much quicker, and you can do way more iterations of figuring out which parts of the space that you're exploring actually matter to you. You can build 10 throwaway things and therefore build up your taste through knowing which of them suck or don't suck.
Right, so all of these have to start with like one person saying, oh, I want to explore the space. Okay, now I want to like do this. And then I get to sit and decide, oh, fine, this is like the thing that connects it. This is why like you end up with these like wipe slop UIs from people who don't know any better.
Yeah, I don't know if any of you have ever looked at a Figma file where the designers, they end up making these explorations that go down and to the right. I don't know if you've ever seen a designer work this way. It's like you go down, you make major iterations, you go to the right, you make minor iterations, and you end up with the staircase of explorations of ideas. And at the end is the final screen that you're supposed to be looking at. And I feel like exploring with AI is very similar to that.
So I can drive the AI to explore. I could just say, don't make it sloppy, use good taste. Or is there more to it?
No, you fundamentally can't.
Yeah, you can't. I agree with Sunil. You have to know what to explore. And I think that's the taste that you have to apply.
And where does that taste come from?
You have to watch good movies, you have to read good books, you have to listen to good music. I'm not even joking. Like every time I hear a VC talking about taste being the moat, and I see that they have like a crypto ape avatar, I'm like, oh, I can't trust this person with taste at all. Yeah. No, this is how you develop taste, by like just reveling in what humanity has to give you.
I mean, I agree. I've been told I have good taste. That's like weird to say that,
like,
but
you have like such a great haircut, and like this is clearly part of your identity. I mean it, by the way. I'm not gassing you up just on stage. Like this is a person who knows how to present themselves.
Okay. I'll take that. But I wanted to plus one. Like I actually agree with like all the pop culture stuff. Like I don't think it's a waste to have watched every single Ninja Turtles cartoon that has been produced. There's a lot of good stuff in there. And extrapolate that to music, art, photography, whatever. It's all good.
So what I get out of this is that I can expense a trip to Napa to taste some wine because I'm developing my DX taste.
You joke, but like, especially the first 2 hours of a Napa trip is good. Past that, I assume you're like not really seeing straight. That's where you need to do your research.
There's a lot of gaudy stuff in Napa, just to warn you. So
okay. Okay, so you talked about the moat as well. We need to get a little bit more controversial here. We're going to get you guys stop being so nice to each other so we get some disagreements going. You talked about taste as a moat. Some people say that, even people that don't have taste. You guys are all three kind of leads of developer experience of the previous generation, the pre-AI era.
He just called us old.
Trying to be nice. But now you are all three heavily invested, all in the AI era. Does the moats that you were able to create with DX before, does that transfer automatically? Like the wine tasting in movies, does it transfer to the agent era? Or do you have to do something differently?
everyone's pausing here.
Like yes and no. Like there is clearly, like I feel so glad that I have, by the way, for the young people in the crowd, you go from being the youngest person in the room to being the oldest person so quickly. I still dress kind of like a child, but like I'm very aware that my back hurts sitting up here right now. I'm so glad that I have a couple of decades of experience behind me to have formed opinions like with my bare hands. I mean, like creating UIs, etc. So I can like look at grid lines and say, okay, this kind of sucks, this doesn't. And especially a couple of years ago, LLMs were like particularly bad at it. That being said, I'm having so much fun right now in doing this exploration because it's not just that AI makes things faster, it's that things I wouldn't have even attempted because it would have taken that much time, I can now do, which means I'm actually trying out more. It's not just a compression. So being able to use Cheng's new pretext library to build a wild UI experience that just would have been out of scope for me like 4 years ago. So like yes and no. Like yes, I'm so glad that I have opinions on how these things should be built, but now I'm actually getting to explore the bits that I just couldn't put the effort for. Does that help?
Yeah, I think the no part is that so many of the skills that we honed, or I should speak for myself, some of the skills that I honed are kind of no longer relevant. Like I type really quickly. Who the fuck cares? I just dictate everything.
That is a huge advantage. I don't know what you're talking about.
It used to be. It used to be.
I can prompt so fast.
I just speak into it now. You know, like I have a whisper mic and I just whisper into it and I dictate everything. And because I no longer need to dictate syntax. Like it doesn't fucking matter that I can type really quickly anymore. You know, and I think there's many skills that we've acquired over the course, or there's many skills that I've acquired over the course of my career that are definitely less relevant than they used to be. I do think that knowing what to work on and knowing what to explore is probably one of the biggest ones that I do still use every day.
Try not to like talk all the time.
Okay. So we could go a couple ways. Let's do this. Right now, going fast. You don't need to type fast. Great. You can go 100x, 1000x. You can run parallel, like for the same prompt, 100 agents. Let's see who does well. So you can go super, super fast. And we see this in products now where, Codex team, others producing software that would have maybe taken years before and doing it, in 2 days. If you have to compete in the market at that iteration speed, how is it possible to have taste?
By the way, I absolutely hate this 100 agents, background agents thing. I understand that the OpenAI people want you to do that. I get so
buy more tokens.
No, 100%.
How many agents are you running right now while we're sitting here?
0. I don't trust these things at all. I need to see reasoning trees.
I have 0 running right now.
Yeah, I think that's.
Yeah, no. So there's a difference between like velocity versus just spray and pray. Like if you actually want to, if you want to stand out right now, you kind of want to do less and be known for a particular way of doing things. Like you have to develop a brand, you have to focus on the things you're trying to do. I say this because, I work at Cloudflare, we ship a lot, but the things we've been working on are things that we have actually been working on for years. We ship we just had a ship week last week and we shipped a number of things. And I looked through all the announcements. I was like, yep, these are things we decided to do 4 years ago. It means that we're still doing the things we want, but we don't want to do everything. And I would highly recommend if you're a builder, you're a creator, you should not try to build 4 products at once. You kind of want to find focus. You want to kill 2 of them and say, I want to build 2 great experiences at the moment. Iterate on that, find explorations in that space. But bro, this entire 100 background agent thing, I just, no, bro. No.
I think, we are still building products for humans. And on the topic of taste, if you're building a product for human, you have to put on your human face and actually try the product and to use it and to evaluate whether humans will enjoy this or they understand it. And that remains the biggest bottleneck, if you want to call it a bottleneck, right? Anyone can make a million things, but whether they're good or whether anyone wants to use them is another thing. So I know in my experience, right now over the last year, using a lot of agentic coding, that is the barrier. And even though we can produce things really quickly, I often look back and I'm like, this was garbage, and well, of course it was, because we didn't even really try or use it, right? I don't know.
I think the area where I find myself having maybe not 100, but a bunch of background agents is when I'm working on a thing that's relatively large that splits up into discrete pieces. And I can parallelize the discrete pieces where each discrete piece with GPT-5 might take 45 minutes to hours, right? I'm not going to sit there for 45 minutes to an hour, just watch Codex do its thing. I spin up another Codex agent and I start working on the other part in parallel. Often it's I'll work on the iOS, the Android implementation, and then the backend implementation kind of at the same time, and just kick through all 3 off, wrangle all the agents back and forth, right? But I don't often find myself parallelizing across discrete tasks, because having 5 things running at the same time and them all working on different things is so much context switching in my brain I can't keep up.
You're running V-test and you got like V-tests on like 10 runners. Do you go and say, yeah, I use V-test with 10 runners?
No.
Yeah. I'm just bringing that up because I almost think this language of like I do use sub-agents. To me, I'm just like, still one agent. Does that make sense? This is like almost like a technical detail.
Yeah, I kind of. Although I actually use separate agents. This is why it feels more separate.
Okay, all right.
Because we actually run all of our agents on dev boxes in the cloud. So you actually have multiple laptops basically in the cloud that you run the agents on. You have to wrangle multiple of those.
I ask these questions, like I even want to know these answers, so.
That's why we're here.
You said something interesting a moment ago too, which is that we build products for humans. Some people are building products these days also for agents. Is developer experience, is DX the same as agent experience? And agent experience we can maybe define as like the tasteful experience, just to use the word in the definition, for agents, the thing that's attractive to them, easy to use, efficient, effective. Is it different when building for agents, for agent experience?
100%. I think until like at least a few months ago, we kept saying, oh, if we design it well for humans, then agents will use it well. At this point, I think that's scope, by the way. Agents have a completely different personality, etc. For example, and I'm not trying very hard not to be a shill, we have a thing called code mode, where we let agents interact with
it's
systems
literally on
by
your hat.
generating code. Oh, this whole thing, I just put it on. I didn't even realize I was going to be thinking about it. We've learned that agents can interact with systems by writing code that interacts with them. So in this assumption, like we wouldn't design it for a human by saying, oh, every human being can write code that interacts with systems. It's a completely different kind of like behavior. And the way I've been talking about internally is that if you really loved human beings when they were your users, you need to really love agents as well. Like where do they hang out? They don't really hang out in pubs. They hang out in like registries. They dream in like syntax errors. You have to like, do you truly love your users? Like you have to like find out what are an agent's desires. And it turns out they love writing code. They love being told like thank you and things like that. No, I'm like 100%. Like this is like 2026 is the year where we actually classify them as different alien beings, and we like learn their personality and like create systems that they like interacting with. Like, can I say that agents like interacting with them? But yeah, like I'm 100% on this, by the way. Like I think we kept saying, oh, like as long as the docs are like readable by human beings, they'll be good for agents. No, screw that. Like dump a bunch of context and tell them to like figure it out. I'm there now.
Okay, we've got 50 seconds left. Let's leave the audience with one sentence, very practical, none of this highfalutin stuff, of how they can have taste in their day-to-day. What does it look like? What's the behavior?
Use 100 parallel codex agents.
We said no shilling. Yeah.
I don't know. Go to an art gallery. Go to a museum. And I bring that up really quickly just to say that, man, I remember 10 years ago, 12 years ago, online personas were way richer in that I learned about how people went and explored the world, and the algorithms today really just make us like singular code monsters or whatever. And so I don't know, just want to make a comment on that.
No, I'm there. Like have friends, go out for brunch, watch movies. It surprisingly affects the quality of the work that you build. You're empathetic to.
Be human.
Yeah, I like.
Thank you all very much. Thank you, panel.
Thank you.
Okay, everybody. So, just a call out. About 400 people are watching us on live stream. Isn't that amazing? All right. For those of us here, there's coffee for you out there. For you on live stream, good luck. Feel free to grab your coffee, go to the expo hall, and pick up a few goodies. Let's be back here at 11 sharp. See you soon. Shout out to
Ladies and gentlemen, please take your seats. Our event will start in 5 minutes. Ladies and gentlemen, please take your seats. Our event will start in 2 minutes.
stage, ready for them. Thank you. Once I see the curtain move, we'll start fading the music. We are ready. Send them to the stage. Not understanding me.
Hello, hello. Welcome back. How's everyone? Anybody talk to new people? Raise up hand if you met somebody new. Some hands going up. We have plenty of breaks for you to network with other people. But now we're back for some more exciting talks. So for our next speaker, you just saw him. So he's in our panel earlier, Ben Vinegar. So I'll welcome him onto the stage. Welcome, Ben. Welcome back. Okay, so I'll do a quick intro of Ben. So Ben is the co-founder and CEO of Modem. So they have a little booth over there. So during a break, feel free to chat with his team. So Modem is an AI platform for PM work. And Ben has been in the AI space for several decades. I'm not going to spoil how long it is because Ben is going to explain himself. So he's going to tell us a little bit more about working with coding agents over SSH. So we're going to transform from local to being remote. Ben, take us away.
Thank you. Hey, everybody. Is that readable? Yeah? Barely? I'll give you one plus zoom. A little better? All right. So hey, I'm Ben. I'm back. Sorry. And I just want to talk a little bit about working with coding agents over SSH. And I just really want to preface this by saying that, first of all, have you seen these graphs before? Are you going exponential from Rise? He was a Versailles at OpenCode. I was shocked to see this, but this is a little bit what's going on in my life just over the last couple months. It is exacerbated because I'm old and I have like a really old GitHub account, so it looks like more crazy. But I have been doing a lot more of this. But this is not a talk about, drop everything, use Linux, use a Marchi. I don't really know that. I'm actually just trying to present this talk to you as like a norm, as like just like a Mac enjoyer, like a normal Mac enjoyer. Okay, and I hope that that's like a lot of you. Like this is more exciting to me. I guess we just had a bit of an intro, but repeat some of it. I've been programming for a long time, mostly web and JavaScript. But I actually started in graphics driver development, which I think is kind of fun. I've spent my whole life working as kind of an early employee at startups. And I've been prompting since 2023. And I mean that to say, for me, the first prompting in like VS Code and Copilot was when somebody explained to me that I could like write a comment, and then I could, and then the like early agents would generate a little bit of what you wanted back then. So I think of that as kind of like early prompting. And yeah, I'm just like a normal IDE user. I like Macs. I've used TextMate, VS Code, all that. So I work at this company. We started it called Modem. And come check out our booth. I won't spend a lot of time just to explain that AI coding is real. Your ability to deliver software faster is definitely real. But sort of the mechanical product work around that, like capturing user feedback, following up with users, like that's still pretty slow. And that's the problems that we're trying to solve. If you're interested, go find out at our booth. How we've been building Modem is maybe kind of interesting and relevant to this. So it's 99% code gen. When we started about a year ago, we made the decision that we're just going to become a completely agentic company, kind of like good timing. I think this is like in the Sonnet 3.7 days. There's 6 engineers, the code base, about 270,000 lines of code, and there's quite a bit of test code. Just to give you an idea of like what we're working with, and as testing is involved, to make that work, there's like a lot of tests. Just as a random aside, and this is relevant to the talk, but like agents love to generate mock tests we kind of throw that out. We make them use like end-to-end database tests. So these tests are actually pretty heavy. So I don't know about you. I have felt this way, but when I go on Twitter and I go online and I see these posts by people who are like spinning up 10 agents in like with like custom harnesses, and they're like, wow, I'm doing all this stuff, and I just didn't get it. I didn't understand how I could work this way. And I wanted to achieve more. I felt like more was possible, so I started to like think about what were the things that were slowing me down, and could I address them? One of the biggest ones, and I don't know, this is a question I have, which is, how many of you run your coding agents in like, living dangerously, YOLO mode 100% of the time? I can't see, the lights are blinding. Everybody? It's like 40% maybe. I think agents are scary. They can do lots of crazy things. I have, stuff on my computer. I don't want things to happen. I've experimented with jailbreaking. You can do it. You can mess with them. So this is like, what would often happen is even if I had approved 1 million rules, I'd often like start jobs and I'd come back, an hour later and discover, oops, you stopped 30 seconds in. Very frustrating, right? Another thing that was slowing me down is just like pure compute resources. Like I mentioned, we like run a lot of, I think running unit tests as part of your like building agents is critical. I'm running them all the time. When you've got a big test suite and it's kind of like hitting the database, man, I would hit, 100% CPU all the time on this machine, even with just a couple agents if they were going through like testing loops. Fans spin up. I could barely browse the web or do anything else. Like that was getting pretty frustrating. I'm on the go a lot. I took a plane here. I wanted to do work on the plane. That's Wi-Fi was pretty spotty. They don't have Starlink on Air Canada. And so often I'm just environments where just like the internet just wouldn't work for me. So one, there are like solutions. There's people who build solutions for this, like cloud agents, or Claude now has like managed agents. I think OpenCode is working on something like this. Big asterisk, this is changing all the time, right? It's so hard to talk about an experience that was like 2 months ago. Could be totally different today, but if I thought about it 2 months ago, I was experimenting with these products that let you build in the cloud, and I just was never satisfied, partly because I wanted to run tests that hit the database. And on Claude, I'd hit a problem where like they have like a sandbox environment with like a network proxy. I couldn't like get out to my database provider. I just got very frustrated. What I ended up doing is even if I could start some work in like a cloud agent, I'd end up bringing it in locally and working on it and like throwing half of it away anyways, and I just didn't feel like it was getting faster. So I considered how I was failing, and it brought me back to Linux, which was sort of like, why am I exploring all these kind of like half-baked versions of Linux sandboxes? Like, why don't I just do the same thing? So the way that I work today mostly looks like this. I have this machine, and then I use SSH plus Tailscale. Tailscale is a sponsor here. I remote into a machine. It's using tmux, which I'll talk a little bit more about these. And then I got a coding agent in there. And I don't know, again, I'm just like a normal IDE user. I've heard about these words like tmux, and they mostly scare and intimidate me. I know just enough Vim to quit. That's like it. So, humor me that when I'm presenting this to you, it's like I don't consider myself an expert. There's probably like 20 people in this room who are already really mad at me for explaining Linux wrong. So, when I did this, first of all, I don't care. People really, Linux distros, they have like strong opinions. Ubuntu's fine. I use Arch. That's fine. If you just want to have one of these, you can go to a VPS provider. You can click a button, and they'll spin up like a Linux environment for you, right now. Right? Pretty easy. If you want to bring your own computer, it's more work, but it's, you probably get more compute. And I think that this has just been like computers are expensive right now for a reason, right? There's a lot of demand on compute, and if that's of interest to you, I think that that's worthwhile. I have a machine that's in my basement. that I've exclusively dedicated to this. It's not a Mac Mini running OpenClaw. It is just a plain computer with a Linux distribution on it. And if you don't want to set up Linux, my tip is let your agent do it. And I think this is like, if you told me, like when I started getting into Linux in the last 6 months, like I just didn't want to do it. But once I learned that like the coding, your coding agents can actually kind of like configure it and get it going for you, it became a lot more approachable. Tailscale is pretty much just like an easy way of connecting to your machines. And they're here, so I don't know that I want to talk too much about this, but you get a private network, connect to your machine. You don't have to go and expose a bunch of ports. Works everywhere. It just lets you connect. And then Tmux is like a window manager, basically, for Linux. You get windows and panes, and I'll show you this in a moment. And if you squint and if you pretend, you can pretend like it's like Mac OS. It supports the mouse, which was like shocking to me, I guess, because I just never really bothered with this stuff. Like actually, like a lot of terminal programs support the mouse, and I'll show you some of that. A big thing that Tmux gives you and its predecessor Screen is like you can rejoin these sessions because you will disconnect. Like I'll close my laptop, sever my internet connection. SSH is gone. I can come back later, and then Tmux will give all that back to me. And then last thing is it's agent scriptable. So I got a little demo here. And so over here, this is Linux running on a VM on my machine. I've tried to do this talk with like a fully remote machine, but I've learned that is like not a good idea, especially if you're like trying to live stream at the same time. Not a good idea. So just to kind of show you right now is like right now, like I'm on my Mac, and then I can kind of get back into my machine. I've got like this little Arch logo here to help me understand where the hell I am. And oh no. Oh boy. Oh, this is the problem when you don't actually know this stuff very well. We're gonna have to open up like a coding agent to help me understand how I can get back to my thing. Well, that's okay. We're over here. Oh, right. All right. I was doing a new one anyways. All right. So really quickly, this is like Tmux. It just looks like a terminal, right? That's what it is. Except you can kind of like have panes, right? I could make more split panes. Hey, I can use the mouse. I can drag this stuff around, which is kind of neat, right? So over here, I can go and I could say like run a server over here, right? Oh my goodness. Well, I've forgotten like how to do all my demo stuff, but anyways. Yeah. Look, when you got the lights flashing in your face, like, and I could open up like kind of a. I can't even actually like see it very well, which is like not what I was expecting. I could open up like an editor over here, right? And then I could even like do, I could have diffs over here or whatever, like whatever, right? And I think this is pretty neat. But like I didn't actually know those commands just a few months ago, so. I'm going to open up OpenCode here. I'll just give you an example of just kind of how I think like coding agents have made this more accessible, which is like, hey, you're in a Tmux session. Open up some panes and put some cool shit in there. That's Linuxy. All right. There it's going, right? So it's firing up, it's creating panes. And the way that I worked with this in a while, and if you're wondering why this is fast, is I'm using Kimi K25 just because for demo purposes, it's the only thing that's going to finish fast enough. But I've got different panes here. What'd you do? What'd you do? You gave me HTOP. You gave me some live disk usage. Digital rain. I don't see that one. But anyways, I could also be like, okay, Now close them. You made bad choices. Okay, all right, so let's bring me back here. So Tmux, if you do want to mess around with it, like you can just start with having the agent like do stuff. And the reason this works, and I didn't load any skill files or anything, is that Tmux is just like you control it using the CLI. So the agent is actually just calling like a bunch of shell commands to do all that. It doesn't need MCP, it doesn't need anything, which is pretty neat. And these are some of the commands it can do. I wish I knew these earlier. Like listing the panes, you can split the window. The other thing that's interesting, and we'll come back to this, is you can read the it can read the content and it can act on it. It can actually send keys. It can actually be like a little driver of them. So if you start messing around with this, you end up having an environment that looks like this. I was pretty zoomed in so that you could see this, but if I'm actually at home, like I'll zoom out and I actually have like quite a bit of surface area. And it's not just panes, you can have multiple windows. So like this is how I actually get 4 agents running is I'll have maybe a couple different projects, packages, and I'll work in them, and I'll have like my whole environment kind of split up this way. So at the end of this, if you go through this exercise, like you can skip permissions all the time because you have a machine that doesn't mingle other data, and if it gets ruined, you can just spin up another VM or whatever. It's not a problem. You get access to more compute, and actually, I just straight up like having other machines do the work so that I have like way better battery life on this laptop when I'm like moving around. I don't have the fans spinning up. I could do other work. I do some like video stuff. That's cool. Always connected, fast internet 24/7. So that 1.0 like megabit stuff is real. I recently took a train to Montreal from Toronto. We do have functioning trains. And that I was only getting, 1 megabit on there, and it was like brutal. I couldn't basically work with an agent. However, on that 6-hour train ride, everything was great because that's just enough for me to connect to the remote session, work with Tmux, have everything working, and so I was kind of uninterrupted. So I guess like my way of getting more out of agents is kind of boring. It's sort of like I don't have agents off in the cloud doing a bunch of independent work for me. I just sort of like more effectively figure out how I can kind of like work with them. So, the good news is you have a remote terminal set up for AI work. The bad news is that the ergonomics of this, like let's be honest, are like not that good. I'm a Mac enjoyer. It's not that great. There are tools built into other platforms like Cursor and VS Code. You can actually just run all this stuff on that machine. So once you can stop before the Tmux part, and you can just kind of like work with the machine over these editors. I haven't done it that much. I have used it to like look and edit and review the code. But hear me out. I think that there is value in like working with some of this like more primitive tech. And just I think a real wake-up call for me is just as like Windows and Mac operating systems have evolved, and now we've got liquid glass, and isn't that incredible? That there's also, actually terminals. The technology that you can run on terminals and the TUIs that exist now have evolved. Like, consider this: the most valuable software created in the last decade is a terminal application, right? Which is Claude Code. That's wild to me, and I don't think it stops there. Right? I think that we're going to see other terminal apps become valuable. So, humor me. I'm going to show you like a little bit of my like if you go all in on this, like what does this look like a little bit? And so, over here, this is my term max demo. So over here I have this is like a Tmux session, and I've got a bunch of different stuff here. Okay, so these are actually like different windows. This is my little custom extension that I vibe coded. It works for me, and I've made it like a bright color just so you can kind of see it. First up, all right, let's just review the plan. Goal, don't embarrass yourself. Good, okay. All right, we're gonna check out this window first, and then I got a bunch of things. So I'm starting here to actually show you. This is an editor called Fresh. I'll have the URL at the end. Like I said, I don't really know Vim. And I tried to give NeoVim a shot. It was way too complicated for me. Fresh is interesting because it's sort of like, hey, VS Code users, do you want to use the mouse? Do you want to do the things that you know how to do? Do you want to have like a control plane where you can actually just bring up files and just kind of work the way that you're used to working. So this is like relatively new software. I think it was built in like the last year. Somebody's working on it. It's pretty neat. I'm enjoying it. It's made like just sort of like looking at code easier. So that's just like one thing that I think is kind of interesting, is that your idea of like what a text editor might be on the terminal has kind of evolved. I could keep going, but where am I? So for example, I can go through some of these files. I think it also shows like modifications in here as well too. Anyhow, oh boy, not enough time. So over here, let's see. This is, I'm going to skip the part. So this is like an OpenTUI app that I've been building. Building OpenTUI apps in the terminal, really great. This is just like, it's very simple. Okay. But I want to illustrate this, which is like, use tmux, look at pane 1, what we got. I think that tmux, I don't look at it just as like a workspace. I actually look at it as like a playwright tool for working on the terminal. If you've ever struggled with like you have logging output or whatever, and how do I get that into my agent? Like when you have tmux, it's easy because it can just read the pane using those shell commands. Does that make sense? Right? And so, okay, I want to change this, right? I want this to look differently. So I have a tool here called termdraw. Termdraw looks like this. It is actually a like vector-based sort of like editor, okay? Where I can like resize things, and I can put, let's say, this here. I'm going to put, let's put close. This is going to be the title. Let's put a line here as well. We got like this smooth line thing, which is kind of fun. This is all over SSH. I'm going to move this, right? And I'm just going to do this. Text, okay? Now send that to my agent. Make the modal look like this. I think there's something about working with the agent where, like, look, it works in text. Like the agent reads text, right? It reads markdown files, and to actually produce artifacts that it actually understands ASCII incredibly well, versus like you give it a screenshot, what is it doing? It's spending thousands of tokens to decompose that into a text description that at the end of the day is not going to have much more fidelity than what I just generated, right? So I think that like sometimes that's kind of interesting. All right, it thinks that it did it. You know what? I'm lazy. Can you run it in pane 1 for me? I don't test a lot of this stuff out, by the way, so I'm just hoping that it works. Oh, I didn't reload it. Oh, you figured that out? You following this? Okay. So I built a lot of TUI apps, and if people are wondering a little bit like how I do that, it is a little bit like this. It's the ability to actually like iteratively have this thing go back and forth. So I'm going to stop you at this point, though, because we're getting there, but you can see how it's going to get there. So let's see. So another tool that I was going to show here is so I built my own diffing tool, and that came because basically if I start working this way, I built my own diff tool that actually like upsets me that that's coming out of my mouth. But ultimately, like I just wasn't very happy with some of the solutions that we have. So I built this thing called Hunk, and it is basically like how can I have something closer to like a VS Code experience on the terminal? I'll show like a better diff, but it basically accepts sort of like diff commands like this. So I could say like main at 3. I can go in, and I can kind of like take a look like this, kind of go like this. And it's got like split view. This is a bad example for split view. It's got word wrap. You can even scroll horizontally, right? So these are like tools that like I never really experienced for diff tools. Anyhow, so let's just go back. I guess the last thing I wanted to also illustrate is that also this presentation is over SSH on the terminal with the rich graphics and stuff too. And it's called Present Terms, so you can check that out. So these are some of the tools I've been using: Fresh, Hunk. I didn't get to show you Glance, ran out of time, Termdraw. And that's, think about it. It's not crazy. Okay.
right, I'm back on. So, how's it going so far?
Do I go back?
Having fun? Good. I'll tell you what, I asked the next speaker if he was forced to delete all of the apps on his phone and he could only keep 3 of them, what would they be? What would they be for you? Think about it. I'm going to reveal his answers. Okay, number 1 was Slack. Then was YouTube. Then was X. What do you think? Do you agree? Okay. Our next speaker is Shashank Goyal. He is the founding engineer of OpenRouter. And I talked to him about how he hires new people and if AI is impacting that. And he said, no, we actually need a lot of engineers. And what he's looking for is enthusiasm, excitement, and people who ask the right questions. And that's his interview technique. Did I say it right?
Yeah.
Okay, all right. We're all set. All right, let's hear it for Shashank.
All right, thank you, everyone. So today we'll be talking about the rise of AI agents, and I'm sure you guys are going to hear this word so many times, and I apologize. And but yeah, so I'm from OpenRouter. We started the company about 2.5 years ago. I joined about 2 years ago and have been building this company. What's special about OpenRouter? We think that we're at a really cool horizontal space in the ecosystem. We're right between all of the different models and all of the apps. We're a model aggregator that makes it really easy to use any model in the ecosystem. As of this month, OpenRouter is doing about 75 trillion tokens every month. We have over 5 million users using the platform every month. There's more than 60 providers and 300 models. What does this all mean? The ecosystem is starting to shift a lot. There isn't just one best model for any one use case. We find that users are using more than one model for whatever workflows that they have. So we saw this pain point a long time ago where it just got really hard if you wanted to use OpenAI models and Gemini models and Anthropic models to know which model to use, when to use it, where to use it. We didn't think that there was a good empirical benchmark. And so we built our ranking page to basically show you not the benchmarks, not all of the benchmarked scores that are produced at every model launch, but like, hey, how are users using these models? Where are they spending their dollars? How are they voting with their actual use? And how do we see this in the ecosystem? So this is one of the charts that we have, which shows what are the top models that users are actually using. And you can actually see that obviously some of the Anthropic models are at the top, but there's a bunch of open source models like DeepSeek, Mimo, there's Minimax, there's Gemini, OpenAI. So it's a very vibrant ecosystem of models, and it's really important to remember that this is really not a winner-takes-all market. Another thing that I really like about the viewpoint that OpenRouter has in the ecosystem and why I'm really excited to share some of the metrics that we have with you guys today is that not only do we see all of the models, but we actually also see what apps are using those models and how they're using them. So the chart that you have on the screen right now but basically shows how coding agent rankings have been changing over time, which agents have become really popular. Some of these you obviously see, KiloCode, Claude Code, but you might not have heard of Hermes agent, for example, and it's an agent that is really starting to engage and gain a lot of popularity. So again, go to the OpenRouter rankings chart whenever you guys have time, but it'll really help you see the ecosystem from this top-down view and understand what models, what apps, how people are using them, and what people are building. But from all this data that OpenRouter is very lucky to have at the top, what have we learned so far? Best practices change week over week, not years or even months. Every week, if you ask me what's my workflow, it's going to look very different. Prompts also need to change as models change, as models get better. So you have to actually tell them fewer and fewer things. And models rotate very quickly. The 3 trends that are very clear from our analysis is that inference is becoming a core internet utility. The same way that if the internet is down, you can't get your work done. If your tokens are down, you can't get your work done. The market is restructuring and extremely dynamic, and agents are now the primary workflow and workload for inference in the market. Over the last year, we've seen over a 14 times growth in the number of tokens consumed. And that basically shows you how much more value users are getting, because every token that is consumed on OpenRouter is $1 that was paid by the user. The number of requests also continues to grow. And there's a slight gap in the number of requests versus the number of tokens, and we'll get into that right after this. Growth in the platform is also decentralized. It's not a single user or a single app that is growing in the ecosystem. And that's true for everyone in AI. So we have like breakout apps like OpenClaw, which have single-handedly consumed over 18 trillion tokens last month. And that really shows how much value users are finding, right? Like we see all these buzzwords. We see that, hey, this is really cool. I like it. But what does that actually mean? Are users using OpenClaw? And this is one of the best metrics to show you. 18 trillion tokens is about $1.8 million that have been spent on OpenClaw just on OpenRouter. And we're a very small percentage of the overall inference market. And it's an open source app where all of the code, you can see it, you can reuse it, you can build it. It's fully MIT licensed. So there's a wide ecosystem here and very easy to build agents because the most popular agents are actually open source. The other thing that has led to this huge spike in token usage is that there has been a pretty significant cost collapse across the ecosystem. When we started with GPT-4 around March 2 years ago, exactly from now, we were at like $30 input and $60 output prices. A GPT-4 quality model is the Gemini 2.5 today, and it's at 15 cents to 60 cents, which is straight up 20 times cheaper, or sorry, 50 times cheaper than the same level of intelligence 2 years ago. That does not mean that frontier models are getting cheaper as well, because we've seen that frontier models have continued to stay the same price. But what is frontier intelligence today? In 1 year will be like 10 to 20 times cheaper than it is today. And so that has a very big ramifications in how we use AI, because you can only deploy Claude 4.7 Opus today on tasks that you know are going to be very high value because it's very expensive. But that's not the world you're building for. You should be thinking about, how do I deploy 4.7 Opus across all of my tasks? Because in a year or even in 6 months, this model is going to be so much cheaper, or this level of intelligence is going to be so much cheaper, which is why it's very important to realize that even though models seem very expensive today at this level of intelligence, that trend is going to continue to push those prices down. Sorry. Yeah, so all of this growth has really changed the models, how they're consumed, and why users are consuming them. I don't expect you to read all of these, but the point is that these are the models that we have onboarded and users have consumed more than 100 million tokens on over the last 12 months. All of these models were on the platform, and we're pretty selective about the models that we onboard to models that have something unique about their architecture, something different about how they were built, and like you're usually pushing the frontier either for their size or for max intelligence. And there's a lot of choice in the ecosystem. No single model stays at the top for very long. This chart basically shows all of the different model families on OpenRouter. So you have Google, Anthropic, OpenAI, et cetera, at the top. But then you do have very significant percentage of usage from Minimax, DeepSeek, Xiaomi, ZAI, a lot of Chinese open source labs that are producing frontier level quality of models. The market is decentralizing. As I've been saying, there are so many models, so the share of the top 5, top 10 models on the market is continuing to go down. And it's very important for the workflows that you guys are building to evaluate them against multiple models, because you will find there's like a big Pareto frontier of quality versus cost. And there's already a lot of trade-offs to be made in the marketplace. maybe not a surprise, but now reasoning is the default. There's still a lot of non-reasoning models like Gemini 2.5 Flash, Gemma 4 models, but now reasoning is the default. All models reason, and users that are using them are extremely looking for models that think before they reply, and it's what we used to call test time compute, or compute during inference is a very important quality of the models that you choose. To specifically call out, in the zeitgeist, DeepSeek might not have released a new model for a long time now. Their last big release came March of last year with R2, but DeepSeek has continued to grow in the market because people are aware of how good the output is for the prices. So it's a model that I would recommend that you all try out if you're building agentic workflows. It's really good at tool calling, and the market corroborates that story. One of the interesting trends in the ecosystem as well is that open source models are the volume leader, but because they're so cheap, the spend percentage is actually way lower. If you can see that they do about 35 to 40% of tokens happen on open source models, but they represent a much smaller percentage of total revenue because they're so much cheaper. And I think it's a really big advantage for people building because there's so many good models available that are much cheap. And combining all of this, the growth in tokens, the growth in models, the growth in ability is, I would say, why agents are now a primary workload on the platform. Over 15% of spend now comes from agentic workflows. The way that we decide if something is an agentic workflow is if there's doing a lot of tool calling, multi-turn loops, they're using orchestration. So we can detect this using metadata, and about 40% of the total workflows on the platform already are agentic, and I can expect to see this continue to increase because models are no longer being used for single question and answer kinds of responses. Even when that's the user interface for the user, behind the scenes, they're making a lot more calls and using a lot more tools to answer the user's question. Tool calls are the main backbone of agentic workflows. For people, I've been saying tool calls a lot, and maybe I didn't define it. For people that aren't aware, tool calls are how models engage with the wider world outside of just their own pre-trained memory. So every time the model wants to get more context, you invoke or take an action in the real world, they use tool calls. And you can see that there's been a really big inflection of how many users and requests are actually using tool calls. In terms of total tokens, what we showed earlier, but basically, it's a really big hockey stick exponential curve, and it's probably the biggest trend that we see right now that has continued to explode in the last 12 months. A very cool insight, we expected agents to be using more tokens, but I didn't expect it to be quite as high. There's a gray line at the bottom of the screen that is honestly a little hard to see because that's about how many tokens that non-agentic workflows are using, tokens per request that non-agentic workflows are using. And you can see it actually hasn't changed at all over the last year. The number of tokens per request has stayed relatively stable, even as models have gotten bigger context, there's more intelligent models. But then if you look at users that are using agentic workflows, it's a totally different story. And this again shows the difference. When you're building agents, you actually can utilize the full context, and it allows you to make much more powerful workflows and experiences on top of models. Agent sessions are also usually 11 times longer. Session here basically means the number of turns. Non-agentic workflows, usually users will ask 2 to 3 questions, but for agentic ones, we have seen them now average turn lengths are getting to 80. So think of the number of sessions that are getting to much, much longer. And I mean, you can think when you're looking at your Claude Code screen, the number of turns that it's doing. But this, again, is a very important chart to understand how different the two workflows are. Why now? Why did agents suddenly become so good? It's really not sudden. It's been a slow buildup over the last year, honestly, year and a half. We had our first reasoning model in January of 2025. Then we had tool calling, but it didn't really work. We used to see tool call success rates hover around 85 to 90%. So that means like 1 out of 10 calls, 10 LLM calls that tried to use a tool would fail. And in agentic sessions where the number of turns can be 80, that's like 8 chances of failure per session. So it was really bad. Over time, like around August, November, is when we really saw like models and model labs figure out how to do tool calling in a more reliable manner. And we saw success rates for tool calling go up to like 99.5% for the frontier models. And that's really like been one of the big unlocks because the models are just way more reliable. We also saw a really big explosion in harnesses around December of last year. So you have Claude Code, Klein, OpenHands, OpenClaw. So all of these harnesses have just made it that much easier to use agents for everyone in the ecosystem. And around January to February, I think it finally all came together. We had Claude Code. I don't know. I've been using Claude Code for like 8 or 9 months, using a lot of different agentic tooling. But I've really felt the inflection in all of the agents I use around when Claude 4.5 Opus dropped in December. And then one more time when people really figured out how to use these harnesses to the best of their ability. So putting it all together, I think finally we're in a world where agents are mostly reliable. They're able to go off and do really long-running tasks without much supervision. And they're able to use a lot of different models and orchestrate themselves to generally know what the best way to build themselves is. And we'll go into that in a second. Putting it all together, the 5 forces that we should all be thinking about as we're building is that models are smarter, inference is cheaper, context is longer, tool calls are more reliable, and harnesses are better. If you have this mental flip for yourself, because it was something that I had to like think about each one because it's changing so quickly. It's easy to forget how cheap inference really is or how good the harnesses are, or like the fact that most of the frontier models now have a 1 million context window. 1 million is you can put a lot of full code bases into the context, so you don't even need grep tools. It just makes a lot of different workflows that were not possible earlier possible now. Agentic flows, when you're building them, also make it so that you can use the best capabilities that the models have to offer. When we look at users that are using agentic flows versus not, agentic flows use more reasoning, they get better caching, they are usually trying out more models. So people that are using agentic workflows are usually trying out 6 different models for their different use cases versus 3 for non-agentic users. And also, like the total volume and request volume is for like agentic use cases. I have a few quick minutes. I didn't want this whole presentation to be just me sharing some data, so I wanted to show you guys at OpenRouter how we're using agents for ourselves as well, taking all of the learnings from the data, but then how do we decide what to build for ourselves? One of the things that we built is something called Spawn, which is basically a one-click deployment for any other user to deploy agents. So if you want to take Claude Code, but then you want to run it in a VM so you can control it from your phone, you can do that at openrouter.ai/spawn. But that's not the thing that I'm excited to share with you guys. What I found really cool is that the full code base that sets up Spawn, all of the integrations with the different agents and different cloud providers where you can deploy it, it's a 100% agent-written code base. There are 0 PRs made by humans in the entire code base. There can be sometimes there are issues that are made by humans, but there's no code that is written by humans. Most of the issues and everything is agentic, fully automated. There are different agents that write code, that review code, that do security analyses, that do issue triaging. We have end-to-end testing agents that are like, basically it's a swarm of agent that runs on this repo all the time. The repo is open source. If you go to this link again, you'll find the GitHub repo at the bottom of the page, or you can just search for OpenRouter Spawn and the GitHub repo should come up. You can actually see exactly how all of these agents are orchestrated in our internal workflows. Scouts is an example of a really simple workflow has added a lot of value. I wanted to put it on here to show that agents don't have to be complicated. Something that we wanted to do was we have OpenRouter is integrated into a lot of open source GitHub repositories, like OpenClaw, for example. And we wanted to track all of the issues that users are facing on OpenClaw. And we tried a few different things. You can just have a cron job that like fetches all of the different issues that are on OpenClaw and sends as a result. But what we found is that every single day would just give us the same results over and over because those were the same top issues that weren't getting resolved. We actually built something called Scouts, also in GitHub, but the Scout agent uses GitHub PRs as its memory. So to create a Scout, you just create a new PR with like a small system prompt. And then there's another agent that looks at all open PRs in this Scout repo and spins off web searches for it. And then whenever the web search is done, it appends to the PR as its own history. So we're using the PR as like the running context for a model. It's very simple. It's a single file in the PR, but then it just made our like daily cron jobs that much better because the model remembered everything that it had seen. The other thing that we've built for ourselves, which has been a total game changer, is what we call ORI, or OpenRouter Intern Manager. We find that when you have a single agent that's trying to do a lot of different tasks, it's way higher chance that it fails. So we love to deploy agents internally that just do one thing, but then they do that one thing really, really well. So there's like a list of 20 agents. Some of them are really fun, like Dexter. We have like thousands of emojis in Slack, and it was getting really hard to know which one to use. So you can ask Dexter what emoji you should use depending on what your mood is. My personal favorite is Buddy. So Buddy helps us onboard any new models and endpoints. Anytime there's a new model, we just tell it, hey, Buddy, Anthropic launched Claude 4.7 Opus, happened on Thursday. And Buddy's able to like fully onboard the endpoint, test everything for us. We use like Sniffer for KYC operations. We have Tony for customer support. So, and we continually add more interns. And each intern gets its own VM and its own GitHub repo. And what we like to say is that it can do brain surgery on itself. So each agent can learn and be better. You can just tell Buddy that, hey, like you didn't have this ability. Can you go learn it? It'll figure out how to do the thing, and then it'll make a repo on make a PR on its own repo. Also, the really cool thing about ORI is that you can ask ORI to spawn more interns, to also remove them if they're not being used, or if we like improve some workflow that we want to push out to all the agents, ORI can do that for us. ORI also does credential management across all of these different agents for us. From everything that we've built, the three things that if I had to say that we have learned is that experiment as much as you can. Production is still hard. That's one of the reasons that we have so many different agents versus just a single agent. And then automate the everyday, because that's really where a lot of the value is. You might not think that something is automatable, but you should just try, and it'll really help. The thing that we keep telling ourselves and are really like forcing ourselves to remember every single day is that we're no longer building OpenRouter. We're building the machine that builds OpenRouter. And having that kind of mindset switch has really helped us automate across the board to be able to ship a product that's used by millions of users with a very small development team and get the most of all of the AI models in the ecosystem. And that's me. All right. Thanks, everyone.
All right. Hope you're all super energized about using OpenRouter and check out all the different AI tools. Now, for our next speaker, we have Nnenna. Nnenna is a full-stack engineer, and she's currently a principal developer advocate and software engineer for Qodo. And she's also a proud member of Women Defining AI, so really trying to build a world where AI is augmenting our lives. And I know there are some quality engineers in the audience, so I think you should definitely tune into her talk because she's going to talk about how to embed AI code quality gates in your software development lifecycle. So Nnenna, take it away.
Thank you, thank you. Really glad to be here. My name is Nnenna Ndukwe. I lead developer relations at Qodo. Qodo is an AI code quality platform. And I am obsessed with AI, but also being able to use it in a very structured way. So that's exactly what we're going to talk about. So before we really begin, I just want to set the tone. I am not a beginner. I've been in the game, the industry for almost 10 years now, just about. And so my knowledge is before this current exciting phase that we're in with AI, and my engineering experience in particular. Whether it was building systems in a fintech company, where we're building investment portfolio management systems with tens of hundreds of millions of dollars on the line, or building a live events platform at O'Reilly, working with back-end engineers to build an entirely new experience for products that generate $1 million+ in revenue. So I've always had to think to some degree about quality for software development. And I am also AI pilled, like totally obsessed. I'm pragmatic, but also super optimistic. And I really do think AI is great for neurodivergent brains, but that's another topic of conversation. So in my journey as an engineer and now with AI, when I think about code quality, I'm always like, where are the touch points of where there's a quality degradation or that there's an opportunity for a degradation of quality? And if you look at the software development lifecycle and a typical workflow, planning and design, development, code review, testing, deployment, this is the entire surface area for where quality can begin to degrade, very subtly or maybe in very obvious ways. And so the opportunity really, the blast radius, I guess you can call it, is everywhere. These are all the places where issues can happen, especially now with AI almost making software feel even that much more fragile. And that's why I think that we are currently building workarounds. We are building workarounds. We are real life architects in this time where we're trying to build around the limitations of AI systems and LLMs. And it's exciting, but it can also be very frustrating. And some of these workarounds are makeshift and others are becoming standardized in real time. And we're just going to see what comes of it. One really amazing example, I'm really excited to give a shout out to Lex for creating GSD. This was a signal, this framework that then became a coding agent built on Pi SDK. This was about structured AI-assisted development. Not only did professional developers at some of the largest companies that we know today started using this tool, also vibe coders wanted more structure. And structure yields quality. So this popularity, 55,000 GitHub stars, this was a signal and is a signal that there is a strong need for quality-driven systems. And I think that's exactly what we should be building. But how do you begin to think about that? And that's what I call, and what we call it at Qodo too, is a verification layer. A verification layer that should be embedded and interwoven into your existing development workflow. So how do you do that? We put on our critical thinking architect hat right now. Number one, you need to define what code quality actually means to you, or what is code quality. There are things that you can research and pull down information from so many different sources and documents to gather that. And there's also very specific requirements that are specific to your projects and the way that you work, or maybe the way that your team or your engineering organization operate. Now, all of that needs to be codified. And it needs to be codified because we are working with agents. And this is context. Once you define it, you need to decide where that codified quality or those quality standards live. And we'll talk more about what that looks like because both of these touch on context engineering. And number 3, you need to design the verification layer where you already work. That's in your IDE, the CLI, Git providers that you're using, CI/CD pipeline. These are all the touch points in your actual workflow for being able to embed code quality. So, step 1 and 2, define and decide where your code quality standards actually live. This is all context engineering. And this is only some of the examples of context engineering, right? I don't even think do people still use Claude MD files? I don't know, since that paper came out about it not being very effective. I don't know. But we have agent markdown files. You've got internal docs and some engineering standards. You have criteria that you might want your code review to be measured against, whether it's manual code review or an AI doing it for you. That's all context. And of course, org-specific policies and any other quality expectations that you might have. This is all context. And these are all the important elements that are needed for the actual pipeline or the life cycle for your development workflow. And a great example of this is Qodo's rules system. So engineers at Qodo built a rules system to be able to have one context plane for managing the agent.md files for all of the rules that could be org-wide or repo-specific or maybe language or framework-specific. They're all listed in one place. And they are also categorized by correctness or reliability or quality and a level of severity. How important is this rule to you per repo or per pull request? So this is what I consider to be the context plane that can be centralized so that when you are working on distributed teams, it's not only visible to you and your team members as a developer, but it's also visible to your agents. And so how do we allow our agents to access this kind of, this context plane so that we can pull it into our dev workflow? And we'll get into that. Number 3, when I mentioned designing the verification layer, we have the traditional software development lifecycle, and then we've got our agents and the agent harness, and then what I mentioned before, our dev workflow, IDE, CLI, Git. And what we're going to do with that context, or what you should do, is operationalize it. And I argue that bringing it into the planning phase is really a strong principle for quality, is actually enforcing quality as early as possible and as often as possible, right? Remember, we're building around the limitations and the unpredictability that comes with working with agents. So bring in those standards early, already in the planning phase. And you can do this by the way that you prompt, and you can do this by using agent skills to pull down that context from your centralized context plane. And then you have your agent skills that you've probably been collecting, like Yu-Gi-Oh cards for code generation. And then what you'll also want to do is for code review is to also enforce the quality criteria again. And so what's important about this is that there's consistency across the stages of your workflow. The same exact rules and the same exact place where the agent skills and different artifacts can be pulled down from across the entire beginning, at least the first half of the development workflow. And that way you can identify, that way consistency is important when it comes to agents, but then you can also identify where there might be quality gaps when you actually are enforcing quality consistently. So these are my skills. They're in Codex app right now. This is what it looks like. There's a ton of them. I've collected them, like I said, like Yu-Gi-Oh cards over time. And a lot of them are related to cleaning up dead code or maybe some error handling that I know that agents seem to just keep struggling with. I also have test-driven development, behavior-driven development skills. But this is just to give you an idea of this is the kind of agent skills that I have and that I actually enforce before I begin implementation. I do this in the planning phase. This is a recent development of mine. And so that's what I mean by enforcing quality early and often. In this example, I'm using Qodo get rules. And this is a skill that pulls down rules from the rules system and determines which ones are most relevant for your current coding task And then those are the rules that are going to be enforced as your agent begins implementing code. And then it's going to go through a verification process as well when it is done. That is a great example, or at least a more sophisticated example of centralized context plane for your quality standards, and then pulling them into planning and code generation. And then I truly believe that a local code review is very, very valuable here. Whether you're working in an IDE, whether you're in a CLI using Codex or Claude Code, wherever it is totally worth it to run local code review against maybe your uncommitted changes or your committed changes, because, well, you want to make sure that anything that could be caught is actually caught before you make a pull request and let the whole world know that you have just generated AI slop. Once you have actually fixed up some of those issues that might have been surfaced from local code review, and you actually make a pull request, you want to be able to leverage AI for that first pass of a code review at the PR stage. And I think it's really valuable to use an AI code review tool that is automated. So as soon as you open up a pull request, and you have, of course, your linters and your tests and your security checks and all of the things that are going to beef up the quality of your process and the code itself, that's when you can have a code review tool automatically run as a first pass and surface any important insights that you can use to improve the code before you maybe have another developer take a look at it, or before you even take a look at it. And I think what's important here that makes this part different from the local code review is that when you have a much stronger system that actually takes longer to run because it's checking against entire code base or multiple repos to give you the important insights that you might need about breaking changes, for example, making an API change here, this contract breaks something in a couple other repos. There's so much more context that I think can be leveraged at the PR stage as a part of everything else that needs to get built at this point that could be different and take longer, but is very effective for a pull request code review. And so this is what I ended up testing out. Of course, this is actually my current workflow, but I tested this process out for a relatively large PR. I say relatively large because I do believe there's stats around your cognitive load of an effective code review kind of degrading dramatically after about 400 lines of code change. So I went all the way to the extreme on purpose, 1,900 lines of code change for this policy enforcement MCP server and CLI tool I'm building, and there was only one bug that was uncovered. And I was shocked. And Qodo is, not to be, of course I'm biased, but we dog food, so I use it every single day. And I was shocked to only see that there was only one bug. But to me, that was proof that my process is definitely working to some degree. With the skills that I have, with the rules that are in place, with all my tests and my linters, this is the proof. And so this was, once Qodo found the bug that I had, which was an unhandled settings exception, I went ahead and fixed it locally in Codex. And what I mentioned before about the robustness of a code review being automated at the PR stage is that it gets to check against your rules and your standards and requirements gaps with adversarial agents. Some folks think that, what is the point of an automated code review bot running when I can just or only run a code review locally with the agents that I use to generate code? And I'm always screaming about this on X. I always say that you need an independent verification layer because of bias from LLMs and because the systems for coding agents are optimized for autocomplete on steroids, right? Optimizing for actually completing code as quickly as possible. So you need a completely independent system that could come in with an adversarial architecture and a goal. And that's when you can begin to uncover some subtle bugs that might exist. And so this is the AI dev workflow checklist for quality. I think you need to define the code quality standards. I think you need to decide where the codified code quality lives in a centralized context plane, especially for folks who are not just solo devs, but you're working on teams and you need that to be distributed and managed. And then you need to pull in the agents and the skills for accessing that context, for planning and for code generation, verifying these local code changes before you make a PR with your static linters and tests, and then automate the more serious, more robust code review process. And a bonus, which is something that I've been doing lately, is automation in AI for iterative refinement of your skills and rules over time. Now, Qodo's rule system is, it automatically can suggest new rules based on the behavioral history of PRs and comments, and it can suggest new rules for coding standards as your code base evolves. But something else that you can do is leverage automation, kind of like a cron job or something that can run weekly and assess all of your PRs and any trends that have occurred, and then decide which new skills are worth creating and which new skills are worth refining, so that you can reduce the types of issues that might keep popping up if there are trends, so that by the time that you get to code review, then some of those issues from the past have already been handled, and you have less issues by the time you get to that last line of defense. And I'd love to show what that looked like. So this is an example of the actual PR that I'm showing you that we looked at. This was the plan that I used. I used Aaron Francis. He has faster.dev. I used some of his audit skills, and I forced Codex, or GPT 5.4 extra high. I forced it to include exactly which skills I wanted it should be able to use or should use for this particular feature change or update. And this is a long list, as you can see here. But this is the structure behind my planning that I force agents to do, that includes scope, the canonical contracts, the component design, the test plan, definition of done. I mean, it's exhaustive. But this is that method of being able to confirm that the agent actually knows what it needs to do, and that there will be a thorough verification implementation process. And that is how I was able to generate thousands of lines of code and end up with only one issue that I needed to fix. And so this is something that I definitely recommend you all begin to think about, because quality really it requires a mindset shift. Security engineers talk about security first, best practices. When it comes to quality and preserving software craftsmanship, no matter how fast and exciting the changes, the evolution of AI that it is, that we get to experience in this domain, that we can still preserve our intellect and our expertise and begin to have agents mirror that in the way that they work and in the way in which that they work for us. And that is my talk. That's what I had to talk about. So thank you.
All right, thank you, Nnenna.
Thank you.
I would like to thank you all for being present. This concludes our morning session. I would also like to thank our audience on live stream. Go get refueled, both for your body and both your LinkedIn connections, and we'll be back at 1:30 sharp.
Ladies and gentlemen, please take your seats. Our event will start in 5 minutes.
All right, all right. Hello, everyone. How was lunch? Well, raise hands if you like lunch. Hey, okay, that was a good lunch. Okay, also some local flair. I really enjoyed it. Hope you enjoyed it too. So, to kick you out of your food coma, we have a very exciting speaker, Jeff. So I met Jeff in San Francisco as well. So fun fact, I've never seen Jeff without an overall and a hat. So that's kind of like the image that I seared in my head about who Jeff is. But he's going to introduce himself a little bit more. Jeff is currently on a global tour, also building on a site, Latent Patterns. So feel free to check out his website. And today he has a pretty philosophical question for us about the change of the economics when software development is cheaper than minimum wage. So let's welcome Jeff onto the stage. Welcome, Jeff.
Hello, everyone. Well, I'm here today with a somewhat provocative title. Software development now costs less than minimum wage. Now, there's always been a difference between software engineering and software development, folks. But I want you to think about this. If your identity function is that you're doing software development, you're typing in the IDE, etc., well, a burger flipper at Macca's gets paid more than you right now. So it's been a year and a half since I first published a technique for managing memory that I affectionately call Ralph. Ralph is really simple. You give a context window, you give it a singular goal, and you let it auto-regress towards that goal with the right backing. So here's me over at Atlassian 2 months ago, giving a talk about, hey, things are changing. The economics of software have forever changed. A week after this, Atlassian did their layoffs. So, folks, the unit economics of business has forever changed. Like, if you consider yourself to be a software developer, like, you can run Claude Code or Codex in a loop AFK, and at API pricing, it's about $10.42 an hour. And that would generate a lot of code. Now, it will generate so much code, it's too hard to review. That's one of the hardest things about this thing. But without a doubt, the economics of business has forever changed. Like, I was at the Cursor meetup back in Sydney, and it was product manager after product manager after product manager, just sharing the latest and greatest thing. And they're having the time of their life, folks. They don't have the psychological wounds. They don't have their identity function removed. They're like, hell yeah, I can build things without people now. Like, people, I don't have to convince people to listen to me. They were just like, yeah, I just made this thing. So it was person after person after person. I encourage you to go outside the bubble of software developers and into the non-engineering demographic and seeing all the magical things they're doing with these tools. And you'll see how things are fundamentally changing, because these head of design and the product manager, they're now software engineers, folks. But it's not just them. Like last month, I'm doing a bit of a world tour, and I was over in Auckland, and I went on a tour of Hobbiton, the Lord of the Rings. And the tour guide was like, hey, Jeff, what are you doing? Like, what do you do? And I'm like, oh, talking about AI. And next thing you know, he's like, wow, how good is AI? I'm able to do like all these polytrade trading bots. And he's just like, what does it mean when your tour guide operator is like token maxing? Wow. Because everyone now is a software developer. I want you to internalize that. Everyone is now a software developer, or everyone is now a coder. So if your identity function of how you derive value is coming from the idea that you are someone who types an IDE, you're pretty cool, right? Because like the PM can mog you. So, but it's also interesting because society is being structured around the idea that knowledge was scarce, right? And with AI, that's flipped. So knowledge is in abundance. It's not just software developers. Like if you want principal software developer level output, you just create a Claude skill for that. What about like entry-level legal, broad skill? Like what happens when the knowledge economy goes from something that was scarce to abundance? And this is what we're facing right now. Ouch. So if we rewind time, about 2 years ago, this was me. I was going, oh fuck. I actually published this. I ran Claude in a loop and I built a Haskell audio library. And the models were pretty good back then, but they required a lot of skill to get some outcomes. But it was pretty clear to see where things were going. Now, you might recognize this moment in time. So this is Christmas last year. So the models are now quite good, but one thing I would part to you, it doesn't matter how good the models get. It takes a period of rest where people will realize the step shift in technology improvements. You see, in the people around me, the people who get the most out of AI put in deliberate intentional practice. Society is kind of like forcing these musical instruments or LLMs or guitars in the corporate to all employees right now. And it's like, please pick it up, please choose some tokens, please give it a strum, please practice. And what we happened in the Christmas break, people actually had some time off and they picked it up. And the models were good now. Like they always were good for the last 2 years, but like they've been RL'd now to a point where they're no longer these wild stallions, like they require skill to break in the horse. They're kind of like this My Little Pony that's just all boxed up, ready to go and to get things going. Now, if you're looking to roll out AI with an organization, the one thing I must part to you is like, musos don't pick up a guitar and give it a strum and go, oh, that's crap, and assume it's always going to be the case. They play with the instrument. And this is one of the things now, like at least for the people in the room, hopefully you've been playing with these guitars and you're learning all these tricks that you can do with these and how different LLM models sound differently and have different characteristics. So I kind of think the world is now kind of K-shaped. Up in the top left, we've got the model-first companies. This is the lean apex predators. They're building AI and they're developing all the workflows with AI, and they're having one hell of a time. And down the bottom there is like everyone else trying to do their people transformation program, figuring out what to do with AI. And would you believe there's people who have banned AI within the corporate? If anyone's watching and AI is banned within your organization, you should leave that organization. Straight up. Now, you might have seen this and a few things like this. My honest take is Jack is right. But my further take here is AI is not factored in yet. What we're seeing is PE ratios and the valuations of SaaS companies return to standard business metric. The fun hasn't started yet. What we have here is not a tool, it's more like a kind of a substrate or polymer that allows us to redefine how business works. You see, for the last 2 months, I've been traveling around the world and I've been catching up with venture capitalists in San Fran, New Zealand, South Korea. And we're just kind of wondering, like the disruption is not just us as software developers, it's upstream in the finance industry. Why does someone need to raise seed capital these days if it's just a 5-man show now? Is software still investable? These are problems and questions at a philosophical level upstream in the financing side of things. The disruption of AI has created uncertainty not just for us as software developers and that, but also in the finance realm. You see, every story needs a frame. So for no particular reason at all, I'm picking SAP Concur. I don't like their expense management software. Would you believe they got fixed overheads of 6,800 people? What? Like 6,800 people? That's a lot of people to do AI transformation. So I think the better question is thinking about like how business has been structured. Business has been structured in a way that we've laid humans on humans on humans as an intelligence layer within organizations. I think this is going to be the year we figure out whether this is true or not. We've already seen companies play with this substrate and changing things around. You see, how long does it take to transform 6,800 people? like within an organization, 2, 3 years. I think the better question is, why would you? Right? All organizations right now are putting LLMs down and encouraging token burn. See, it's not about like the leaderboard and token maxing. It's just literally seeing if someone is actually curious. Like if they're not burning tokens, they haven't found a way to burn tokens, and they're not losing sleep because like, oh my God, all the things they can build. It's really they're failing a pulse check. And there's a lot of people who are failing pulse checks right now. So why would you transform them? You see, we know that organizations and like you run events or party management, like the less people, the better. Like the social complexity is there. Smaller teams get better outcomes. And here's a story from a founder in New Zealand. We're smaller, but we effectively cut 2/3 by telling our board that we wouldn't backfill. That's almost 2.5 years ago, folks. Almost 3 years ago. They stopped backfilling. So you might see all these things saying, oh, we're making these changes to staffing and hiring. It's already been happening, folks. And it was the best decision because it got rid of all the people who are sick of hearing about AI. 20-ish people now produce 30 times the output 3 years ago. I want you to think about this and let this sink in. Because one of the hardest things about AI is it's kind of been forced upon the world non-consensually. Like it's just, you've got to put your chin up and get through it. Like for a lot of people, they're specialized in doing these like Game of Thrones type, social hierarchy, Dilbert type stuff. And it's all going to be for nothing. Because if you're a founder and this is your own capital, why wouldn't you compress the org chart? This is going to be really interesting. Because as we get these lean apex model-first companies, they're going to operate on cheaper, they're going to operate much cheaper and on leaner margins. So it's not like the founders will want to do this, they're going to have to be forced to do this. If the experiments this year with all the founders changing around the org chart pay off. It's going to take one business study. Next thing you know, they're all going to start copying. They're all going to start reorganizing their organizations. So experience today as a software engineer does not guarantee relevance in the future. This has always been the case. There was a time when a software engineer would move on from a company because they weren't adopting cloud. They want to keep their skills relevant. Our profession has always been a travelator. And one of the scariest things is really just how fast this travelator is going. You see, if a company's having problems adopting AI, well, that's a company issue. It's now my literal problem that I think about, like help companies with. It's not an employee issue. You see, employees trade time and skill for money. And I'm really worried that people aren't investing in themselves. It's crazy. Like, here we go. Here's something I published about 2 years ago saying some software developers are not going to make it. Well, I no longer hire on the left side of this anymore. Like, why would you? And it's crazy. There really is now 2 categories of employees. Those who are consuming Cursor, Windsurf, what else have you, and all the AI token things. And the other class of engineer is someone who actually knows the fundamentals of an agent and knows how to automate things. And they're a senior engineer because they can teach the next cohort and generation. It's been 2 years, folks. There is a huge amount of people that you can hire for that have this knowledge. You try to figure out who to hire for in your interviews, quite literally pull someone out and get them to explain what a primary key is. You see, but I'm not talking about a primary key. If I was to ask you what a primary key is or like what a linked list is, you'd be like, Jeff, like, come on, are you bullshitting me? Is this a shit test? But like, it's surprising so many people can't answer this fundamental question. You're trying to figure out who to hire for as a startup and like who's going to make it, who's not going to make it. It really is this question. Like, do they understand the big, scary boogeyman, the AI monster, is literally a while true loop that automatically copies and pastes information into an array? Can they draw a sequence diagram explaining how this all works? This is what you should be looking at. I like to call this a curiosity test. And unfortunately, way too many people are failing this curiosity test. Software development has changed in the last 6 months more than the last 30 years. If they're not paying attention, like what the heck is going on? So you might be wondering, why wouldn't you save someone in the center, like they're stuck here in headlights? It's because it's a psychological thing. They might run back up the hill. They plan their career at FANG and they just want another couple of years, so they vest and they quit. Like you really, at this point, you need to be just someone who is understanding AI and is a good software engineer and is learning techniques how to keep the agents on the loop and developing taste and music. So it's going to be really interesting to see how this pans out, folks. Really interesting to see how this pans out, because like if we start seeing layoffs and job cuts, I don't think they've even started yet. What happens to the people who get displaced? They're going to need jobs. And what are they going to do? They're going to get a job at the next employer and they're going to do what was done to them. And this is my concerns, it could be somewhat recursive. But the best thing you can really do if you see someone who is like stuck in the headlights and like, oh crap, what's going on, is like to build an agent. I was in San Fran at a Codex meetup. I put my hand, I called out to everyone like, hey, who here can actually draw me a sequence diagram and explain to me how inferencing works and tool calling works? 5 hands went up out of 200. Like, holy crap. Like, it's the numbers who understand these things are crazy low, and this is one of the most amazing things you can do right now is to build your own agent. I've got a repo on GitHub. It's got a couple thousand stars, 300 lines of code, and what you do is you have the agent, and then you use the agent to self-improve itself. And then you build with a recursive latent space, and I think that's something that causes someone's head to completely flip and switch. And you go, well, this is just a chat app. They're like, cool. Do you want it to be a TUI or do you want it to be a web app? They're like, oh, web app. Okay, prompt for it. You're like, what the hell? I just saw self-evolving software. Yes. This is the one thing that I can highly suggest and nudge people if they're still stuck in the center, is build their agent and get them interested in the idea of evolving the software. The software builds the software. It's going to be really interesting to see how this pays out, because for a lot of people, they haven't noticed that AI isn't knocking up at their doorstep because it's burrowing under their house. And this is really, really scary to me, thinking about this. So many people haven't actually paying attention to what's happening. The closing ponderoos. Removing waste from your company is probably one of the biggest accelerators to AI. If you got like, I've had clients that have had like a repo per design atom, like they're using Polymer, like 200 plus repos, checkbox, a repo, a text box, a repo. Get rid of all that waste, folks. Like, monorepos are love. Mainline that, because agents don't cross the boundaries very well. If you got your primary source of truth for how systems work in the architecture document in Confluence, and then some in Markdown and across the organization, fix that stuff, fix the waste. Maybe you didn't hire enough designers, right? Maybe that you made your software developers mushrooms instead of product engineers. Fix that stuff. It's only until you fix that type of waste until you really get the acceleration with AI. And the organizations who are invested into testing and all the things that they should have been doing, they're getting accelerated by AI. Meanwhile, the big brand, they're having problems with AI. It's like, you know, in that organization, they had no testing policy and they haven't prioritized it. So no shit, they're having problems adopting AI. They had low standards. There's an old saying that ideas are everything. Ideas are worthless and execution is everything. But what does it mean if you can just like rip a fart into Claude Code and it builds that idea? Like, really, just to go to Dax, how he opened up, thinking about what to generate is really hard, folks. It's really, really hard. Like, good ideas are shockingly rare. Shockingly rare. You should be spending a lot of time thinking about what the right thing is to generate. And not only that, when you have an idea, generate like 20 varieties of it and touch it and like hold it and play with it, like, and figure out whether it's good. And that's how you develop taste. Now, I keep mentioning identity functions. This is something that's kind of weird. We used to have like tribes in software. And it's like, oh, what are you? And they, oh yeah, I'm a Ruby developer, I'm a PHP developer, I'm a Golang developer. And we had sub-tribes. Do you use NeoVim? Do you use Emacs? All that stuff doesn't matter anymore. It's all been erased. And that creates for people kind of like a wound, a psychological wound, because it's all been erased. None of it matters. All that matters now is you're a software developer. I would expect any software engineer to be able to pick up Rust within a couple of days now, or PHP, or what else have you, because it's all been made fungible. And that's going to be really hard for a lot of people to stomach. But one thing I can say is, if you see someone stuck and with this psychological wound, get them to build an agent and get them to use that agent to self-improve that agent and paste evolutionary software and recursive latent phase. And I found that like 10 out of 10, that snaps them out of it. Because I don't want engineers who can just like downloading whatever comes on Hacker News. I want engineers who understand the inner fundamentals. Like I don't want a mechanic that just switches engines. I want a mechanic that's able to explain what a piston is, what a tool call. Engineers are meant to be curious. Thank you.
Okay, thank you for the great talk.
Thank you.
So your model is returning low quality responses, and the provider is selling you garbage tokens. Who's to blame? Yes, quantization. Today on trial, we have Philip Kiely trying to redeem himself with the talk, how to quantize models without killing quality. Good luck.
Hello, everyone. How's it going? So wonderful to be here today. And wow, Dexter was not lying when he says you cannot see. It's just the lights. The lights are bright here in Miami. I am here to talk about quantization, everyone's least favorite thing when they're trying to run their agents at peak hours. So I'm Philip. I've heard that to make yourself easily identifiable, you should not use a group photo. So I put up a photo of myself with all my buddies from Baseten. We're that company you see in pink and green all over SF if you're out there. And I work on inference every day. That's what this is. So what is my agenda today? What are we going to talk about? We're going to talk about why models are so slow. We're going to talk about what is quantization. We're going to talk about the great gift of NVFP4, aka a great way to sell you Blackwell GPUs. We're going to talk about what is safe to quantize within models, what is more risky, and then take a look at some real-world performance and quality results. But, I mean, that's like the agenda, right? But what's the agenda? Why am I here? What am I trying to sell you? People are really suspicious of quantization. You know, all of those greedy inference providers are out there trying to rip you off, selling you poor quality tokens at frontier prices by just squishing their models into these little tiny 4-bit number formats. And it's making the tokens sick. You can see that they're weak and sickly tokens. And ChatGPT did not necessarily realize that I meant LLM tokens, so they gave me Bitcoins. But we're just going to pretend that these are LLM tokens. You know, there's a lot of discussion on the internet about how quantization just nerfs models. You know, that second bullet point here, you know, if maybe under the hood people are sneakily and suspiciously quantizing models down to tiny data formats. And, you know, so some people are pretty cool with quantization. Dax was also up here getting involuntary LASIK from these lights this morning. He, you know, he's good with it. He says some of the highest quality providers serve models in FP4. You know, maybe there's more to quality than just quantization. So who's right? You know, I'm just trying to give you cheap tokens, bro. Like, quit coming after me for this whole quantization. I just want your inference to be cheap and to be fast. and for your LLM tokens, because I fixed it on this image, your LLM tokens to be frolicking through a field at like 30 to 50% faster speeds. So how do we get there? The thing about inference is a hard problem with a lot of moving parts. And the thing that I don't want you to take away from today's talk is, oh, there was this one magical silver bullet thing called quantization, and you do it to a model, and it solves all the problem, and now your inference is fast and cheap. There's actually dozens of different technologies and techniques working together to make inference effective. That's what makes it such an amazing field to work in. But today, we're just going to take a close look at one single technique for one single part of the stack, which is quantization, because again, it's the one that everyone complains about. You know, no one's ever starting any Twitter beef over speculative decoding or tensor parallelism. So let's take a look at the hot topic. All right. So we've got various levels of inference engineering knowledge in this room. I was actually talking to someone yesterday who did a graduate thesis on quantization. I was like, oh, you want to just like give my talk for me, please? But she's talking about something else. And some people who are a little newer to the field. So we're just going to start with some basics. If you've run a model on a GPU, just like take a power nap for 2 minutes. I know we are right after lunch. So LLM inference has two different phases, a prefill phase and a decode phase. And generalizing here, prefill is bound on compute, how many operations per second you can do. And so to make prefill faster, you want access to faster cores. Decode, on the other hand, that's the tokens per second part. If prefill is time to first token, decode is tokens per second. That's bound on memory bandwidth. How fast can you move data from the VRAM into the L0, L1 caches to actually use them for inference? And for this, we need to move less data. So, in inference in general, actually, it's not just for LLMs. For, image and video generation as well, you can be compute bound. And for audio transcription, speech synthesis, et cetera, you can be memory bound. Quantization helps with both. It's one of the only model performance techniques that actually helps with both your compute problems and your memory bandwidth problems at the same time. So let's take a detour back to the old days of computing when we talked a lot about compression. Compression has been around for a long time. If you've watched Silicon Valley, they made a whole 6-season TV show about a compression company. And we've gotten really good at compression. These two images you see up here, the one on the, just putting myself in your frame of reference for a second, the one on the left is 4 times bigger than the one on the right, but they look identical. Maybe if I took the one on the right and I blew it up onto a billboard, you might be able to see the difference. But here on my screen, at least, it looks just fine. So how can we do the same thing for models? Again, with quantization, the problem with models is all these kernels, Gem et al., they take a long time. You got to read the data off the VRAM, and then you got to do the matrix multiplication on the cores. And so the solution is, what if you just had smaller numbers that you were working with? What if every time you moved 100 megabytes through the VRAM, you were moving twice as much information to the model? What if you were using cores that were twice as powerful because they're operating at a lower precision? Quantization is kind of this magic thing that increases your effective bandwidth, it increases your cache residency if you can do KV cache quantization, works with any model and any modality to solve any bottleneck. So why doesn't everyone just love this thing? Well, the problem is that generative AI models, they exhibit emergent behavior. You throw some stuff in, some things happen, and then an output occurs. These are the sort of technical insights you come to a Philip Kiely talk for. And the problem with some things happen is that we all know that inference is non-deterministic. We all know that a bunch of stuff can happen. If you're effectively rounding a bunch of your numbers and multiplying those together and compounding errors throughout the inference process, maybe you're still going to get the result you want. Maybe you're not. Maybe your logits end up skewed just slightly. Your prediction probabilities end up just off. And then your next token ends up being ACT instead of ABS. and then you get up on stage and just suck in your gut for 25 minutes so that you act like you have abs. This can be a problem in your inference system. So, the other thing I want to talk about, just to sort of disambiguate this really quick before we jump in, is I'm mostly talking about post-training quantization. Increasingly, AI labs are setting the model's native precision to be somewhat smaller so that they can take advantage of advanced inference without losing any of that quality. But we're talking about the stuff that's under your control as an individual developer pulling down a model off of Hugging Face, the post-training quantization that you can do at inference time. So this has the model weights for our purpose. They're already baked. They're already done. We're not doing any further distillation or fine-tuning or RL or any of that kind of stuff. The model's ready to go. It's already as smart as it's going to be. We just want to make it faster and hopefully not make it any dumber. So let's take a look at that. Let's take a look at where we're starting and where we're moving to. Doing OK on time. OK, so the data formats. You can represent the components of a model. Those, if you think about Kimi with 1 trillion parameters, we've got a bunch of matrices that have 1 trillion different numbers in them. How big are each of those numbers? How many bits are we using to represent those numbers? And what format are we using? Are we using an integer or a floating point? Floating point numbers have 3 different types of bits within them. There's the sign bit, positive or negative, and then the exponents and the mantissa. And so if you think about the way you construct a floating point number from these bits, it's a 10 to the power of a thing or a 2 to the power of a thing times the mantissa. And that gives you something called dynamic range, which we're going to get to in a second. Now, part of the problem with quantization, part of the reason it has this really bad reputation, is because a lot of these floating point formats are relatively recent. So if you look here, oh, good, you can see my mouse. This is fantastic. So in this sort of 2022 era when Hopper and Lovelace were first rolling out, they brought with them the concept of FP8. Blackwell brought with it the concept of FP4 for inference in production. And before that, when we were doing quantization onto Ampere, onto Turing, or onto local hardware, in many cases, these were integer quantizations. And integer quantizations, not to cast shade, but are not very good. And so the sort of industry opinion of quantization was formed on integer quantizations. Now we have floating point quantizations. Let's see if they're better. So dynamic range is the thing here with quantization. It's the ability to encode very, very small values and very, very large values on an absolute basis. Floating point formats use the stuff we were talking about, the signs, the exponents, and the mantissas, to preserve dynamic range. If you think about a FP16 number, your sort of standard format for a model, you start with 5 exponent bits. That controls kind of how big and small your numbers can get on an absolute basis. When you move to FP8, you still have 4 of them in most cases. You've actually only lost 1 bit of dynamic range, even though you've shrunk substantially. When you get down to FP4, though, which is where we want to go so that we can do really fun, fast stuff on Blackwell, you lose 2 more. And now you're kind of cooked in a dynamic range perspective. So what do you do about it? You're trying to map all of these values from this massive range down to literally just 16 buckets. If you think about a 4-bit floating point format, you only have 16 numbers that you're representing what used to be 65,000 numbers. How do you do it? How do you put all of these numbers into these buckets? Well, you cheat. You have something called a scale factor that allows you to record additional information while trading off keeping track of more numbers and doing more math. You can have a scale factor at the tensor level, at the channel level, or at the block level. And today, the best small scale formats are microscaling data formats that use blockwise quantization. You have a couple of general purpose ones, but I'm not here to shill general purpose things that you can run anywhere. I'm here to shill NVFP4 that you can run on NVIDIA Blackwell. And the difference with this format is that you actually have 2 scaling factors and a smaller block format. So your blockwise scaling is a n equals 16. That means each block level scale factor is applied to 16 numbers. Why is 16 important? That's how many different values you have. So now you can use one value for everything and then put a scale factor that maps that block appropriately. And then to make sure that you get a whole ton of dynamic range, you do a secondary FP32 global scaling factor. Now, keeping track of all of this stuff is hard and expensive and slows you down a little bit, but it's all baked into the Blackwell architecture, so we can just forget about it and run NVFP4, and our life is great. It provides increased accuracy because you have your block scale factor is now a E4M3, so you have some mantissa in there for specificity. You get your extra exponents from your tensor scaling factor, and life is good. That's my talk, everyone. Just use NVFP4, and everything's easy. You're done. Oh, wait, we're not done. OK. There's still some other things you have to do besides just use the magical data format that only works sometimes in some cases. So the big question is, like, what can you actually quantize? You know, there's a sort of spectrum of pretty safe to, like, why the hell would you touch that in terms of your parameters and your model. Weights, these gigantic linear layers, are, like, pretty safe to quantize in most cases. Generally, we see a lot of success pushing those all the way down to 4 bits. Activations in KV cache, maybe like a year or two ago, that was even kind of risky to put in 8 bits. Now we're getting pretty good at putting it in 8 bits. And attention, don't touch attention. Just leave it alone. It's hard enough. Just let it do its thing. So generally, you don't quantize attention unless you are, you know, feeling really, really lucky that day. So the, you know, if you want to take a deeper look in, you know, what parts of the model to quantize, check out my friend Ali's blog post on Twitter called 4 Bits, where he goes super deep into, for an image model, some of these different layers and what is and what is not safe to touch. But in general, not all layers are created equal. For example, your input and output layers from that weights block might be more sensitive. You might only want to quantize some of the interior layers. You might only want to quantize, you know, part of the, you might want to, for example, in a vision language model, leave the vision encoder alone because it's small and it's more sensitive, and just focus on the main LLM layers. There's all kinds of sort of model-specific specificity and sensitivity that you want to account for in this quantization process. So it's always important to keep that in mind as you're working. The other thing, of course, to keep in mind is the hardware and kernel support. Just because NVIDIA says you can quantize something to a certain format and run it on a certain GPU does not always mean that you're going to be extremely successful in doing that in production. Again, a lot of the open source work and the kernel work is still targeting Hopper, is still targeting that FP8 quantization. So if you're trying to run NVFP4, you should expect to have to do a lot of porting to get something like a deep gem kernel up and running on your new Blackwell architecture. There are other factors to think about in terms of which models you can and cannot quantize. You know, the biggest one is model size. All else equal, like, models with more parameters are more resistant to negative quality impacts because any individual outlier that might have gotten smoothed over in the process is not as important in, say, like a trillion parameter model as it is in a billion parameter model. You can also, of course, within the architecture of the model itself, introduce quantization-aware training, which labs are increasingly doing. If you look at, for example, GPT-OSS, that has an MXFP4 native quantization, which is one of the reasons that models had so much staying power on the market, because it does, you know, resist quantization very, very well. And then the final thing to think about when you're, you know, actually the one hands-on doing the quantization is the calibration process as you're using, for example, NVIDIA ModelOpt or some other tool to apply the quantization, calculate what the new weight should be, calculate your scale factors. You want to do those under conditions that very closely match production usage. For example, if you're using a chat data set and you're going to use your model for code generation, that's probably not going to give you a very appropriate calibration output. Cool. So we've done all this hard work. Let's see if it was actually, you know, good for anything. So to review, quantization was bad because we had these integer-based data formats. We were quantizing small early models like a Llama 7dB or something. And we were doing it in a sort of generic way a couple years ago. where quantization was not applied or calibrated super specifically. And that's how quantization got this bad reputation as the lobotomizer of models. And today, quantization can work because we have floating point formats, we have quantization-aware training, and we kind of, sort of, at least a little bit know what we're doing. So all of that to say, like, does it actually work? Does it actually do anything? And here's the other kind of gotcha with quantization is like, you might look at the spec sheet and be like, whoa, I can get like 4, maybe 3.5 times faster just based on my flops and VRAM bandwidth, and that is just going to translate linearly to performance gains. It's not. Or you could look at your kernel profile and say like, well, if every single one of these becomes twice as fast, I'm going to get like 1.9x faster. You're not. Generally observed gains from FP16 to FP8 or FP8 to FP4 is like 30 to 50% with every step. So it's definitely a sort of more limited observed real-world gain. But still, I mean, 30 to 50%, that's an extra, 60 tokens per second. That's 100 milliseconds off your time to first token. That's a few $1 million off your inference bill. It's a big outcome if you can, confidently get your model there. So that's where the quality checking comes in. You've got to, first off, I mean, everyone always says, look at your data, look at your outputs. This is my sort of counterexample to the compression image that I showed earlier. We have here a full precision tiger and an NVFP4 tiger. Can anyone tell me the difference between these two tigers? Or can anyone notice that I actually switched the labels on you? They look exactly the same, but the one under full precision is actually the NVFP4 tiger, with, of course, the same seed and the same settings and all to get this very, very identical output image. And then for something that you can't just look at, maybe something like an LLM, a more complex agent, you can look at a perplexity score. You don't want your perplexity to go up. You can, of course, just run your same eval set on the original weights and the quantized weights and make sure that everything is within a comfortable margin of error of noise. You can do spot checks, always check your function calling, long context, all that kind of stuff. And if it's not quantization, your model could feel dumber because of the reasoning effort, because of the chat templates, because of a new checkpoint. There's all kinds of other reasons. So quantization can be bad, but don't blame it for everything. Quantize if you want to make it faster, and you can do so without making it dumber. Thank you all so much. And I'm just going to take a few seconds to plug something. You can get this book. I unfortunately did not have enough room in my luggage for everyone. So if you scan this QR code, hop on the wait list. I will send you an email when I get Shopify up, and you can DM me a picture from AIE Miami. I'll send you a code for a free one. Thank you so much, and let's have a great time out here.
Whoa, Philip, that was a very energizing talk. For the next one, I hope you all are going to go bananas for this one because we're inviting the Google DeepMind team who's going to be talking about generative media, so including your favorite models like nano bananas and more. Okay, so I'm going to introduce my colleague Alisa and Guillaume. So welcome to the stage. So Alisa and Guillaume are from Google DeepMind. And they both work for AI Studio. So if you haven't heard about it, they're going to do a demo for us today. So super exciting. And I'm going to let them introduce themselves a little bit more. We have a dynamic duo of a PM and a developer advocate. So they're going to walk you through the creative world that you can get in with AI Studio and generative media. So take it away.
Hi, everyone. My name is Alisa Fortin. I'm one of the PMs on the Google DeepMind team, and my focus is generative media models, specifically image, video, and audio models. This is my partner in crime.
So hello, everyone. I'm Guillaume. I'm Alisa's partners for all of the Gemini models launches. I'm developer advocate, meaning that my job is to represent all of you inside of Google and to make sure that whatever we release is easy to use and coherent for developers so that you can easily make things with our models. We are going to talk about generative media, but just a word about the Gemini, the vision of Deepmind for AI models. Right, like from the beginning, the vision for Deepmind was to make multimodal models because we believe that we need the models to be able to understand as many modalities as possible, so videos, audio, sensors, speech, and so on, kind of like of 5 senses, and to also express itself in all of those modalities as well, and so to be able to generate images, videos, and so on. So most of the things we are going to talk about today. And the reason we want that is because that's what we call world models, and we want the model to be able to understand everything about the world and to act on it.
And before we continue, we are going to do a bunch of live demos today. I don't know if it's actually going to be helpful, but maybe some phones can go on airplane mode. That might help our live demo. We were practicing, and the speeds are kind of slow. But thank you. We'll be prepared. So why do we love working on Gen Media? Think about the 3 words: entertain, communicate, and learn. Open your phone. You will look at the world. There's media around you. When we're improving these models, we aren't just like tweaking code or training data. We're actually helping teachers teach, helping businesses connect with their users, and we're helping creators create. So that's what we're building, and that's why we're so excited to speak about this with you today.
And we are shipping a lot of things at Google, and that slide is just about the Gen Media models we are having. We have the video ones here, the image one with Nano Banana. We have Genie 3 that we shipped quite recently as well. And so we know that we are shipping so much things that it's hard to keep track of all of the offer. And that's the reason why we wanted to do this talk and to show you the different models that we have and to give you some tricks and do live demos about what you can do to improve your usage of the model.
So this brings me to the first model I'm going to talk about. So when you think about kind of the past and how the camera was used to capture the reality, generative video actually brings your imagination to the real world. And so that's why VO is so exciting, and we're just at the beginning of what generative video can do. When we work to create these models, we always think about how can we make it accessible to as many people as possible. So we're thinking about those creators, we're thinking about the teachers, we're thinking about the small businesses and how they're reaching their audience. So that's why VO has a family of models, and the most recent model that we introduced is VO 3.1 Lite, which is basically our fastest, it's our most cost-effective model that will allow you to quickly prototype and bring things to production. So when you're looking at our models and you're kind of thinking, which model should I pick for my use case? This will be kind of similar across all of Gen Media. You're going to use VO 3.1 Lite or a fast model when you need to quickly prototype something, do a bunch of generations at speed, post a bunch of videos on social media, and then when you're truly building like something cinematic, you need the 4K outputs, you're going to move to our flagship VO quality models.
So just a very quick tips about how to get something better with VO. And as we said, we are doing live demos and it's all never working. So, but very quickly, one of the things that most people are doing when using VO or any generative media models is let's try a prompt that is very representative of what we get. And that's the thing, like most people are just sending prompts that are just too short. And the shorter the prompt is, the harder it is for the model to know exactly what it has to generate. And so it basically has to fill the gaps. And that's the reason why the first tips that we can give you for any Gen Media model is to actually write long prompts. The longer prompts possible you can write, because you need to reduce the number of things that the model will have to invent by itself. So that's the reason why I made this quick demo that is basically using Gemini to take your prompt and to enhance it to be better and to have more details about what it needs to generate. And the good thing with that is that if you get, the longer the prompt is, the easier it's going to be also to take the video that you made with Veo 3.1 Lite and to make it better, larger with the standard model. Because if the prompt is very detailed, the model is going to know exactly what to do and do more or less the same thing each time. And if you want to go even further, you can use what we called JSON mode, and basically just using a very, very big JSON with a lot of fields like titles, creative summary, as you can see, for each character, the name of the characters, the visual descriptions, attire, hairstyle, accessories, and so on, where the location is, what the art direction is, and so on and so on. The point of this is to be thorough and to have this kind of checklist of all of the things I need to tell the model so that I'm sure that it's going to do exactly what I want it to do. And you can see that we even have like those chunks of what's happening between the first second and the second, and what's happening in the next 2 seconds, and so on.
I think one thing to add about JSON prompting is that we don't actually, our evals don't show that JSON prompts work any better than the natural language prompts. But if you're structuring a prompt in your head and then you want to update things like, you know, timestamps and what's happening and then small backgrounds, JSON allows you to keep that structure and make these minor changes.
So see, that the kind of things you get with a proper prompt that is describing everything you want to do. That the generation was a bit slow, so I ran it before. But let's go back to our slides. And Nano Banana now.
Next one, where's your bananas? Everyone's recent favorite, Nano Banana. And just like with all of our other models, we have a family of Nano Banana models now. So to give you just a quick TLDR as we're running out of time, when you're looking at Nano Banana 2, you're looking at quick prototyping. You may need draft-like resolutions, 520 pixels. You may need lower cost. This is what you're looking at, the workhorse model, Nano Banana 2. When you are ready to go to more high fidelity, photorealism, natural outputs, this is where Nano Banana Pro still excels. And all of our Nano Banana models support a variety of aspect ratios and resolutions. Basically, we want to make sure that we meet all the project and asset needs that you have today.
And one of the core features of Nano Banana, since Nano Banana Pro, is that it's able to use search grounding. So basically go on the internet and search for information about what you are asking it, so that it can give you the latest information. So you can ask it about to make an image about the news from yesterday, about the score from a specific sports game. And for example, in this case, look the way for me and make an image that just represents my work and everything I did in my past work.
And then recently with Nano Banana 2, we actually introduced grounding with Google search for images. So, you know, as generative media models, they're great at the actual rendering and the outputs, but what they're really terrible at is facts, right? So if you're trying to prompt for this top right, you see there is a bridge that IU bridge in Pakistan that we were trying to represent here, and then we asked Nano Banana Pro that only has search grounding to render a watercolor of this bridge. You see how it missed like the structure of the bridge and how complex it is. Well, Nano Banana 2 actually grounds the responses in the image as well. So it's not just hallucinating the output of what it thinks the bridge should look like or what the training data says it should look like. It's able to view the image of this actual bridge, and you can see how the bridge on the top right is rendered with more accuracy.
So once again, one quick tip for Nano Banana. One of the first things is that you need to remember that the model was mainly trained to do multi-turn editing. So you give an image and you ask for edits on the image. I know that most people are using it to generate image, but that's actually not what the model was meant to be initially. It's also very good to use references, so you can give it a lot of images that you want to reuse as this is my character, this is the scene, and so on, and that's how you get the best results. And there was also, like, we get a lot of requests because people were kind of disappointing about that, how to get like transparent background. So I made this quick app that I need to reload currently, just to show you different the way I'm using to create transparent background for images using Nnenna. And I think we're running out of time, so let's go with the pre-run one. So basically, this was a manatee partying in Miami wearing an AI engineer cap. And the way I'm doing that is that I'm creating a first image and asking it to create a white background. And then I'm asking it to change the white background to a black background. And the thing is with Nnenna, it's that it's pixel perfect. So when you ask it to change an image, it's not going to touch any of the pixels that it doesn't need to touch. So then you just need to do a diff. And everything that changed between the two images is going to be the transparent background. So that's how you can get very easily transparent background. And there was another neat trick that I wanted to show you in case you want to create like lots of images using Nnenna. You have different ways to save on cost. You can use batch. You can use the new flex service level that are both reducing the cost by half. But there's actually another very neat way to reduce the cost. And I'm just going to jump right away to the results. But basically, the trick is to, instead of creating multiple small images of 512 pixels, create a big image in 4K, but ask for it to be a grid with multiple images. So in this case, I'm just asking for an AI conference in Miami named AI Engineer. And the model is actually going to create 64 images representing this prompt. But deep down, it was actually one image that was a grid, and then the model, and then I just had to cut the image to get my small images out of it. And if we just check on the prices, it cost me the price of one image. So instead of 64 ones, even though they were smaller, so I'm saving 95% of the cost that way. And that even works if you want like all kind of different prompts. So this one is 24 different prompts, and the model was still able to create those 24 different images within one image right in one time. So that's a kind of neat trick if you want to save on costs with Nnenna. And now let's move to the latest addition to our Gen Media models.
Yeah, so Lyria. Again, the Lyria model family is our flagship song and music generation model. Again, we're offering you two different models. The first one is great if you're doing like quick loops or you're doing quick promo audio, because it's a 30-second generation song. And then the Lyria 3 Pro is actually our kind of flagship model that can generate the full song, and it allows for a lot of control to support different parts of the composition, and also it can take different multimodal inputs like images to make a song based on any image that you provide. And then of course all of the songs can be in different languages. So just like with all of our models, when you're prompting, the models do take natural language, but it does help to have the structure in your mind for how you're going to prompt for these songs. And so Guillaume, you just take it away with a demo.
Yeah, so the thing is with the model, what's really cool is that you can prompt it in different ways, and one of the easiest ways you can say, this is what I want in the intro, this is what I want in the first verse, this is what I want the chorus, and the second verse, and so on and so on. And the model is going to build this song based on that. And for each of those prompts, you can say the style of music you want, how energetic you want it to be. You can even say the scale or set the BPM for the whole song, and it will create the song according to what you did. So I just like it's generating at the moment. I don't know if we're going to wait for it. Maybe sometimes it can take 1 minute. But we can check the one that I generated earlier with the same one. And I asked the beginning of the song to be, we don't have the sound. Can you enable the sound of the laptop, please? No? Can we have the sound of the laptop?
Can we get the sound working?
Thank you.
Perfect, thank you.
So and then it's speeding up because we asked for the verse to be, I don't know, a mix of cumbia and salsa with Spanish lyrics. And then if we fast forward, I think it's going to be even more dynamic.
I think like one thing to add here is that if you're using the 30-second model, your prompt needs to be able to fit within those 30 seconds as you're generating your timed durations. And then if you're using the full song model, obviously you have a little bit more creative freedom. If you go to Google AI Studio, you can check out Lyria and the special composer mode, which allows you, yeah, Guillaume has it right here. It basically allows you to construct your prompt the same way that you might be passing to the Gemini API.
Yeah, and let me show you another very cool demo with Lyria as well, because Lyria 3 is not actually the first model, the first music generation that we released. We have this other one that is named Lyria Real Time, and that's instead of creating music using from a prompt, it's creating music in real time, as the name implies. And basically, it creates, as soon as you start, it's a live model, so it will continue to create music as soon as you make it work. And this demo is basically, you are in this world of in space, and every planet is a prompt. And when you move around the planets, the music changes in real time. And one of the cool things, so I never know how to find it, so but there's a place where there are Christmas songs, and just next to them there's Scandinavian metal. So the mix can be quite fun when you mix them all. But I think we're just going to have to go with salsa, I guess. But see, it's very cool the way it just mixes things in real time. And there was another demo that we wanted to show, is this one. So you wanted to try this one?
I want to try it, yeah. Okay, are we ready?
No, currently. Need to reload again. Okay, let's go.
Hey DJ, can you hear me?
The spirit. You're live on air with the Jukebox DJ, and we're about to create an absolute banger together. So, what's the vibe we're going for, and what should this sonic creation be all about? Lay it on me.
Okay, let's create a song about really sunny weather in Miami and make it Latin style.
Oh, lovely jubbly. Miami sunshine and Latin flavors? That's a proper summer anthem right there. Now, are we talking about sipping mojitos on the beach, dancing till dawn, or something a bit more chill? And what kind of Latin style specifically? Salsa, reggaeton, bachata? Give me those details, mate.
Yes. Whatever, yes.
Get going.
That was not listening either.
Absolute banger. I need a little more info, mate. Spicy like salsa, or something smoother? What's the story? Just sunny days, or maybe a summer romance? Hit me up.
We can't hear what it's saying because
we can't hear.
Salsa.
Salsa.
Top of the pops. Salsa it is. Picture this. Pure sunshine.
Yeah, you know, that's kind of the problem with LLMs. Sometimes they are way too talkative.
Right then, some folks just love a good chin wag, don't they? Making music happen. Hope you love that salsa track, mate.
I'm glad you're aware of it.
Too right, mate. Always happy to keep the energy up and make some noise.
Okay, let's move on because we are already out of time. Let's up.
We have 13 seconds, but we were supposed to do the song in French.
Yeah.
Next time.
Up.
Okay. So what you? Oh.
That's static noise from the thing.
So quick note, the Talkative DJ is actually our recently released new audio live model. And so my next slide is we're going to talk about audio real quick. We have a new text-to-speech model, Gemini 3.1 Flash. If you're familiar with text-to-speech models, they take your flat input text and then they will generate some speech. This model is actually the model that's powering everyone's favorite podcast feature in Notebook LM. And so with this new update, we're basically putting the user in the director chair. You're not only delivering the flat text for the model to then speak, you actually have more granular controls with using the audio tags to control how the model speaks and what emotion essentially it's producing. And then, of course, we're supporting multiple different languages with the 24 languages that we've recently optimized to make sure that they're delivering on like the highest quality and make sure that they have the native accent.
So very quickly, a very quick demo here. So one of the things is with this model is that you can actually take any voice. We have a bunch of hard-coded voices, but you can prompt them specifically for the ways they should be talking. So you can say, this character is going to be a style of vocal smile, whatever it means, and speak very fast and with an American accent, while the other is going to be speaking with like a newscaster, rapid fire as well, with also an American accent. And here's what it does.
Welcome back to the show. Today we're diving into the intersection of AI and creative expression.
Exactly. I've got so many thoughts on what happened this week.
It really is shifting daily. I mean, did you see the demo they dropped on Tuesday?
So the cool thing is that you can change that in real time, not in real time, but in the text you can say this next sentence is going to be very angry, and then the voice is going to change the way it talks in the middle of the sentence or things like that. But what I wanted to show you is another neat trick. If you want to create discussions with more than 2 characters, you can actually do that, and that's what I'm doing here. So I'm basically creating one discussion with 5 astronauts trying to bake a cake on the International Space Station, and for each character, I'm creating one prompt for each for them. And then instead of saying just a discussion with the 5 characters, which would not work with the model because it's limited to 2 voices, I'm actually sending it. If you check here, is that this is going to be the first character who is using the low pitch voice. I'm using the low pitch and the high pitch voice, and then I put the full prompt that represents this character, and then the next one is going to have its own prompting and so on, and that's actually giving you a discussion with more than 2 voices.
Team, we face our greatest challenge yet. The funfetti.
It's ridiculous. Flour is getting into the ventilation. We will choke on the sprinkles. Oh, do not be a spoiled sport, Svetlana. It is simply a matter of whisking with enthusiasm. Pip, pip. Actually, if the centrifugal force of the whisk exceeds 3.4 Gs, the batter will atomize.
Whoa, dudes. Floating. It is a yellow space orb. Capture the orb, Chuck. The mission depends on it.
So you see that it's actually using the same voices, but you get the feeling that it's different voice. Like each characters are actually their own voices. I see it basically as when I read bedtime stories to my daughter and I do voices for each character. That's the same, but the AI is slightly better than me at that. We are out of time, but like very quickly. One of the cool things with the Gen Media models is that you can mix the models together. And I actually gave 2 weeks ago at AI Engineer London a workshop about how to do that. So if you want to check it, you can follow this link, and all of the content of the workshop is there. I guess the video is going to be uploaded anytime soon as well, so you will be able to see that. We were planning to ask you what you needed to in the models, but since we are running out of time, our job is to basically get feedback from you so that we can steer the models into the right directions and get the actual user in the models, and instead of what the researchers think the user needs. So if you want things from the models, please fill this form and tell us what you're missing, and so that way we can use your feedback to make the models even better.
The very short form goes directly to me, so then I can bug research to build things that you will actually go use in the real world.
Yeah, that was.
Really quick.
This one?
We didn't skip. Oh, we didn't skip any
We didn't-
slides. No, we just went quickly.
Yeah.
Okay, sorry.
Yep, then that's enough.
Thank you. Thank you, everyone.
Yeah, welcome.
All right, awesome. A note to presenters, do not skip any slides, please. Our next presenter works at the intersection of AI, data engineering, security, and governance. And she's going to share with us how she built an agent with scale and security in mind for enterprise use cases. I'm excited to invite Anna on the stage. And her talk will be on from tickets to PRs, shipping a governed Snowflake Ops agent with LangGraph and MCP. Please welcome Anna.
Hello, everyone. They weren't lying. You really can't see a thing up here. So I'm going to pretend I'm just talking to myself. I'm back in my hotel room practicing the speech. But no, I'm actually super excited to be here today. This is one of my favorite projects that I've honestly ever worked on. So I'm here to talk about how I built a governed ops agent specifically to operate our Snowflake operational work at Pinterest. Now, I'm going to focus a little on Snowflake, types of requests we were getting, right? But I want you to look at this as a reusable pattern, something that you can apply to your own operational work. That could be infrastructure setup requests, IT help desk, ops requests. It could be data access to other data systems. Whatever it is, I've purposely abstracted away some of those details so we could focus on the pattern, how we approach this problem, and how we chose to solve it, right? There we go. So just very briefly what I'll be covering. First, the problem and why an agent made sense for this, right? Why I'm even here talking today. I'll talk about the workflow, some of the design, some of the guardrails and controls we added, and lastly, what made this shippable and what you could walk away with today. And that's the end of my presentation. Okay. Oh, there we go. Okay, so as we know, as LLMs get more and more advanced, they can solve more and more complex problems. However, the technical complexity wasn't the issue for us. It was actually that we had a lot of routine, repetitive requests that just took manual time to solve. So in the case of Snowflake, we're getting access requests, we're getting schema creation requests, IP allow list changes, things like that, which very repeatable flows. Like we have to check what roles exist, who needs access to what. Maybe people already have permissions, and it just takes time. So people are sometimes waiting days for their ticket just because it's in the queue, right? So this is going to be a challenge. Oops. Okay. So this isn't screaming agent right now, right? It's saying we have opportunity to automate this. And that's true. If you look at the first three items here, the ones without the red border, right? We've got reviewable output. So my team was solving these requests, and we would generate SQL script you run against Snowflake to grant permissions or make whatever changes you need, right? We have a repeatable process. In the end, right, everyone's asking for access to some data. Sales needs access to this. Marketing needs access to this. The use case varies. The data sets vary, the roles, permissions, et cetera. But very similar, repeatable processes. And we had certain control points already built in, right? So when we're building agents, the goal isn't to move away from PR reviews. You don't want to move away from approvals. You don't want to remove those. Maybe you already have standardized deployment workflows like we did. You want to maintain those where it makes sense. And actually, those are the guardrails you should be placing. But still, those three, you're not going, you needed an agent for this, right? No, that's still screaming, here's the path to automation. But it's this last point, contextual reasoning, using LLMs for what they're good at. That's where we really saw the opportunity to build an agent. So at Pinterest, we purposely abstracted away some of the nitty-gritty details of like Snowflake role hierarchy, our naming conventions, how we set up different teams' access. So people don't always know what they're asking for, and that's on purpose, right? You don't want someone to get caught up like trying to figure out the naming convention if their team has a role. No, we've allowed them to ask really like simple requests like the sales team needs access to this sales data set. Our agent and what LLMs are good at, they're good at understanding text. They're good at gathering context, doing lookups, doing searches. So that's why we really leaned into this and built an agent. That, and it was really, really super fun. So I didn't mention this earlier, but this actually started as a hackathon idea that we built in 2 days. But the road to production took a long time. And that's why I'm here to talk about this today. Like how we think about security, governance, different controls we need to add in. So before I deep dive into the architecture and a little bit more on the design, I want to give you 2 key framing principles that drove how we approached this problem. The first is my secret to building a good agent. A good agent needs a good mascot. So anyone who works with me knows I love to name my agents. I love to have a fun mascot. It just makes building them so much more fun. But on a more serious note, and something to keep in mind once it loads. There we go. Match agent authority to workflow risk, right? So when I say authority, I'm talking about what can the agent do? What should it not be able to do? And then think about risk. Think about the systems you're working with. Think about what data you're touching, right? So for us, in the case of Snowflake, we have sensitive production data we store there, and it's a SOX compliant system, meaning any processes we build out on there, any agents, have to be auditable, right? We can't have agents modifying our data and messing with our reporting. No. So as you think about this, as you think how it applies to your own operational work, think about what authority you give your agent and think about the risk involved. I'm just pointing this out because this drove part of our design, but maybe you have scenarios that are lower risk. Maybe you can give the agent more authority. So in practice, right, that principle I shared, that means what can the agent do, what can't it do? So specifically for the agent we built, what can it do? And here we really leaned into what LLMs do best and where our team had a lot of our bottlenecks, right? So our agent does a great job interpreting requests, seeing what details someone gave us, what's missing, gathering context, doing those lookups, figuring out, yes, it's a data access request, what's needed, what roles, what permissions, generating SQL code. LLMs are great at that. Opening GitHub PRs. But that's where we decided to draw the boundary and to hand it off to governed workflows, right? So what we decided our agent can't do, it can't write to production, it can't modify any data. Even though it's generating metadata queries too, it can't actually run those just in case something goes wrong, right? It might drop our entire data warehouse. It can't approve its own changes, but we can have other agents do code reviews. In the end, it really just can't act without constraints. You have to define those boundaries. So to share more about the high-level architecture, I like to break it down into these three parts of it, right? We've got the intake. No matter what your use case, you're going to have requests coming in somewhere. Jira tickets, Slack messages, other ticketing systems, right? And then the agent, that's where all the magic is happening. So we designed our agent as a lane graph workflow. And I'll go into why in the next slide. But here are all the different things it can do, right? Parsing a request, taking that messy, ambiguous request someone gave us, turning it into structured output, looking up metadata against Snowflake, doing all those lookups, generating SQL, generating the PR even, right? We have LLMs wired into all those steps. So even for PR creation, why not have the agent generate the PR summary, right? Once that PR is out there, though, we hit what I'm calling our governed execution part. We always have a human in the loop, especially because it's a SOC system, right? We're always going to have a person review the output, make sure it's accurate, syntactically correct. The agent didn't come up with some wild permissions to grant. And then we still don't give the LLM or the agent the keys to our production system. Even if it generated the right SQL, there's no guarantee it's actually going to execute it correctly, or it won't insert some additional queries and drop our database, right? So we stuck with our standardized deployment workflow. You can maintain whatever CI/CD processes you have now, and then apply those changes, right? But if you think back to the problem, we had processes that worked, right? We were really just trying to solve for those manual pain points, the queuing, the bottlenecks. So we use the agent where it works really well. So if you're looking at this point, my team now doesn't even know requests are coming in until we get pinged that there's a PR for review. Or worst case, the agent has to escalate something to us that needs some manual intervention. This is what I'm going to remember for the dead clicker. All right, so I said I'm going to touch on why we went with LangGraph specifically. So in reality, operational workflows aren't one-shot things, right? You get ambiguous requests. People say, like, I need this, and don't give you half the details. Even when we standardize our intake for the Snowflake request, we put a question, right? What level of access do you need, read or write? People will still leave that out, right? So the agent has to go and ask them, and then wait for the user to provide more detail. Or in some case, it's a valid request, but some of our request types require some approvals. So in the case of data access requests, we always have data owners, right? So it's not up to the agent to decide, yeah, you could have access to super sensitive data. No, it's always the data owner. So we're waiting for approvals. So if you look at this, you see we've got entry points, re-entry points, exit points, very specific branching. And the agent needs to be able to maintain state or know where it left off. So this is what LangGraph is really good for. So if you're not aware, LangGraph is a workflow orchestration framework for stateful agents, right? So we actually maintain state on the ticket right now. Once the agent leaves off somewhere, maybe it's an invalid request, it'll mark that on the ticket. So then it knows where it left off. This way, you don't have to rerun the whole workflow. The agent can pick off where it left off, right? You're just waiting for an approval. You know the ticket was valid. Unless someone went and changed something, which might trigger a different state, you don't have to rerun the whole validate request step. All right. And part of my talk title did mention MCP, so Model Context Protocol. So I'm going to touch on that. But in the last slide, we have our LangGraph workflow. You might be thinking, this feels like such a rigid, deterministic flow, right? It always has to do this step, followed by this step, followed by that step. And I'll point out, it's just the flow or the steps that are deterministic. We still have LLMs used at different stages, right? Those are always going to be non-deterministic, and that's something we have to think about. But in this case, it feels like we didn't give the agent a lot of autonomy, right? And it might be super tempting, like, now we have AI, just let it do everything, right? Take in this request, solve it, one shot, go. No. You should really be thinking about where autonomy will help. Where should we scope that autonomy in, and at what level? So a step like validate request, it's just a one-shot prompt, right? You get your ticket, we defined a prompt with criteria of what's a valid request. And it'll go valid, invalid. With the gather context step, and part of the reason we even built this agent was because it's not, there aren't like 3 predefined queries you always have to run to solve a request, or very specific steps, right? It's use case by use case. So we actually have a metadata sub-agent that has access to the Snowflake MCP server, and it's going to look up different things against metadata views. It iterates, right? It does a lot of iterative reasoning. And I'll actually show you the tools we gave it. It does a lot of iterative reasoning. So it'll run a query. That tells it something. It figures out what other information it needs, runs another query, keeps going, and then turns all those query results into structured output. And again, if you're thinking about how to apply this to your own operational workflows, this one's very Snowflake specific, but maybe you have Zendesk tickets, Jira tickets, some other system. You could give it your own MCP for that system, right? You're just giving it the keys so AI could talk to those tools. It could do its own lookup, look up different states, different searches, figure out what it needs to find, gather that context, and once it has all the information it needs, it's going to move on to the next step, which for us was generating the SQL. The other step I want to highlight, though, right, you saw on one of the previous slides, we always have a human in the loop. So we could have generated the SQL and just gone, created the PR, triggered a PR review, right? But I want to highlight this review and repair step. And my point here is, don't blindly trust the first pass output, right? We've kind of designed the agent to work well, use it for what LLMs are good at. We actually chose to use SQL templates for this. So it's not like, here's a template, here's what the output is always going to be. But no, Snowflake has certain standardized queries, right? You're trying to create a role. There's a create role if not exists grant. We told the agent, it's up to you to figure out how many roles you need to create, if you even need to create one. Just use that. Don't go crazy. Don't hallucinate. Don't come up with your own. Don't make assumptions about this, how it's done. This is how Snowflake queries work, right? So we gave it those templates, but there's no guarantee it's going to stick to those, right? There's no guarantee it's not going to insert a semicolon where there shouldn't be, stick it in the role name, right? So we've actually told it, you generate your output, actually validate that. And here you can choose whether it makes sense to use an LLM for the validation or whether you want to have more deterministic checks, right? We chose to go with an LLM because they're great at generating SQL. They're also good at reading SQL. So we told it, right? Make sure it's syntactically correct SQL. Keep in mind, it can't actually execute these queries because it doesn't have write permissions on Snowflake. So it's just reviewing syntax. It's reviewing the original request, making sure what it output actually solves that request, making sure someone didn't ask for Jira data and it's granting access to all the data in the data warehouse, right? So we give it a chance to review its own code. And if it finds any issues, we give it a bounded number of checks to repair those. And it'll repeat a couple times. And if for whatever reason it really can't solve it, it's having issues, or just went off track, at that point we escalate to a person. And that's when someone from my team will go and manually resolve the request. We also have other escalation points built in throughout the workflow. I just didn't show them on the graph. But this way you just give the LLM a chance to, or the agent a chance to make sure it's correct. Any day now. Please. All right. It finally worked. It just doesn't like me. I think I was talking too fast, maybe speeding through it, so it wants to make sure I go a little slower. So I could go into more technical details. There are more flows. There are more branches, right? As we expand this agent to handle other high-volume asks, it might get more complexity. But in general, it's going to have very similar steps, right? Validate the request. Some are going to have data. Some are going to have approvals. We'll always generate some SQL or whatever. You could generate Terraform config as code, a set of steps to run, right? But what made this shippable, right? Like, why did we get the OK from security and legal to deploy this on a SOC system? So I kind of already highlighted these points at the beginning, but just to summarize and give you points to think about as you build your own agents. First off, start with bounded work, right? For us, it was high volume requests, things that were causing pain points, bottlenecks, but that had clear, repeatable steps, clear outputs, right? We always knew we needed to generate SQL queries, or we always know we need to generate config as code. And then reasoning without authority, right? It's up to you to assess the risk of your system and decide how much authority to give it. And again, in our case, we had really sensitive data. We had a sensitive production system, so we needed to give it less authority. But you see, we actually built a successful agent and never had to give it write access to Snowflake. But again, assess the risk of your system and decide. Maybe you can use LLMs to take certain write actions. Or maybe you're in the same boat as us and it's too risky. But agents at the end of the day are going to be really good at reasoning, really good at understanding requests, right? I mentioned this at the beginning, and I'm going to mention again. Reuse those control points. We're not building agents to try to get rid of PR reviews. We can have those code reviewed agents. They can speed things up. But at the end of the day, you still want a human to sanity check even the code review agent output, right? Or if you have working CI/CD workflows, don't try to incorporate LLMs where you don't need them, where things are already working. Next one, scoped autonomy, right? You saw we have a deterministic flow, but we chose where to give it a little more autonomy, right? And again, for your use case, maybe you could have a less rigid flow. Maybe you just have 2 steps in your LangGraph workflow, right? But add it where it makes sense. Don't try to make it solve everything in one go, right? And my last point is design for re-entry. If you're thinking about real-life operational workflows, if you could get it done in one shot, that's great. But realistically, you're going to have exit points. You're going to have cases where the agent needs more information. You're going to need approvals, et cetera. You're going to have different branching logic, escalate to a human, right? So. Please? There's one line I just want to leave you with, which is this, and I think I got this point across, which is useful agents need boundary, not more authority. And that's going to be the key to actually launching a lot of these agents in production. This is what's going to make your security teams, your privacy teams, your legal teams happy, right? You could give the agent access to everything, sure, but there's more risk involved. There's more that could go wrong. And hopefully I've shown you that you don't need to do that. You should just use LLMs, agents for what they're good at, where it makes sense. Choose to use deterministic workflows or existing code where it makes sense. And I don't know, go build agents. Thank you.
Thank you, Anna. Sorry about the clicker. We will have to build AI agents to make that work better next. Yeah, but well, despite all that, Anna was able to finish her talk. So let's give it up for Anna. Okay. So this is an exciting moment because we're gonna go on a break. So we have quite a bit of time for you to just talk to each other, grab some coffee, maybe go outside. It's really nice outside. Some logistics before we break, but if you didn't lose your parking ticket, you can feel free to already mingle with other people. Just come back at 3:50 p.m. We're gonna start our final talks of the day at 3:50. However, if you feel like you missed your parking ticket, I have something that I need to read. If you're missing your parking ticket, we found a ticket from Garage 4 yesterday at 12:40 p.m. So the volunteers at the check-in table will be holding on to the ticket. So if you can't find your ticket, go talk to them. Or just talk to them for fun, because they're really nice people anyways. So with that, we're ready to break, and I'll see you at 3:50 p.m.
Ladies and gentlemen, please take your seats. Our event will start in 5 minutes. Ladies and gentlemen, please take your seats. Our event will start in 2 minutes.
All right, welcome back, everybody. Our next presenter is an open source superstar, an educator. He's doing a lot of things. Frankly, I couldn't memorize them. I'm going to read them for you. He's the creator of epicweb.dev, epicai.pro, the Epic Stack, epicreact.dev, and testingjavascript.com. And more recently, he's launching epicproduct.engineer. He's a well-known educator and contributor to the open source community. It's my pleasure to welcome Kent C. Dutz on the stage.
Thank you. Hello, everybody. Thank you so much for having me, AI Engineer Miami. I love Miami. I'm super excited to be here and talk with all of you. I'm going to be talking about building a free agent, which I think is a fun, clever title, but it's free as in freedom, cookies. I don't drink beer, so it's cookies, and puppies, as in something you have to take care of. So what do I mean by that? Well, you're going to have to wait a second to find out, because I want you all to stand up. Please stand up. If you're physically able to join us, please do. It's been like a long day. You need blood flow for your brains to work, so put your arms out in front of you like this, squat down, and back up. That one doesn't count. That's just a practice. We're going to do 12 of these. I want you to count out loud with me. Ready? 1, 2, you're doing great. 3, you can go really low if you want. 4, or just like a little dip. That's fine too. 6, 7, do you feel that blood flow? It's so good. What are we on? 1. No, just kidding. I forgot. Are we at, is that 10, 11, and 12? Thank you. Okay, stretch over your head as high as you can. And then over to one side. And over to the other. All right, that feels great. Okay, sit down. Thank you. Yes. Blood flow makes your brain work better. So, exercise. We are not robots yet. Okay, this is the view from my office. Can you believe that? Yeah, I'm looking at that all day, and it's super great. But it's not always super great, because sometimes you get glare, and it's especially bad in my kitchen because it reflects off of the countertop. This is not my kitchen. My wife would not want me showing all strangers of the internet my kitchen. This is my office, though. Whoops. Yeah, there. That is my office, and it's great. Yeah, glare is not fun. So we do have shades. Again, not my home. And they can avoid the glare. And so I actually have like automated shades, and it uses some, if anybody's familiar with Power Shades or Nice Viewer or Elan or whatever, but it's nice so I can like control things, but I really, really like my view. And actually, even this view is a problem if I get overcast and now the clouds are all super bright and now it's shining into my eyes, and I do use light mode, but it's not enough and it hurts. And so I would like to have some mechanism for me to say, when the lights, when the sun is in this position, or when it's overcast, then lower the shades or raise them up. I want them to be up when they can be up, but not when I'm going to get something like this. And so I decided to solve this using AI. Of course, we're here at AI Engineer. But the way that I solved this is with a little program or AI assistant that I call Cody. And this is actually Cody, my mascot for all the stuff that I do. And Cody is now my AI assistant. And so now, thanks to Cody, my shades will stay up as kind of the default, but then they'll go down for privacy reasons in the evening. They'll go down when the weather is overcast. And actually, in my office specifically, it will go down. Just that little section that's going to blind my eyes. In my kitchen, it goes down in the afternoons when the sun is going to shine off and reflect off of things, and it calculates where the sun is in the sky. I think it used a word like azimuth or something. I don't know any of that. I love AI. And so now, like, I can just live my life, and my shades just move as they need. Oh yeah, and super annoying if the shades move when I'm recording, and so it knows my lights. My lights are also integrated into this experience. And so if my recording lights are on, it knows I'm recording, and so it's not going to change the shades. It's awesome. It's pretty cool. Let me tell you something else that I did with Cody. This is a game that I told Cody to build for my son, who is 2.5. And so he finds the right thing, he clicks on it, and he gets a little celebration. If he gets it wrong, then it blows up, and he has to go click this one. He actually really likes seeing it blow up, so he'll do this. And then he'll see the confetti. So this is a fun little game that I had Cody build and deploy. I didn't have to log into anything. Cody was already logged into my Cloudflare account, and so deployed it and everything. Actually made this OG image using browser run from Cloudflare, which is pretty cool too, and it's all going through Cody. I don't have to do any of that. I think some of you might be starting to get bored, and if you're not, then I'll tell you why you probably should be here in a second. This was a very exciting live stream screen catcher. You can see I'm very excited. I'm actually wearing the same shirt, incidentally. But super excited because I built a Spotify player that integrated with my own Spotify. But I used Cody to do it, and that's why I was excited. What was exciting about this was that the integration flow, how that worked. And I'll show you a little bit about that, too. I also had Cody set up a Docker container for Navidrome, which is a self-hosted music application on my NAS. And I told it to wire it up with a Cloudflare tunnel so I could access it outside of the internet or outside of my local network without exposing ports on my local network. Cloudflare rocks. I'm not sponsored by Cloudflare, but I think they're pretty great, and I use them for everything that Cody is. But all of that worked. We're not having to do any of this stuff ourselves anymore, and it's pretty great. And then I was lying in bed. We had just purchased Epic Product.engineer the day before, and I had my team working on that. If you're curious what that looks like, you can go look it up right now. It's a real site, and you can give me your email address. But I was like, you know what? Epic.engineer would be pretty cool to have, too. So I bought it when I was lying in bed from my phone, and I told Cody, go build me a landing page. And it even integrated with my Kit. So that's my email mailing service, so it could actually set up a real subscription and everything, deployed it on Cloudflare, made the OG image for me, everything. OK, so at this point, lots of you are like, bro, that's awesome. I'm so glad that you rebuilt a worse version of OpenClaw. That is kind of what I did. But OpenClaw is not, and I've opened the OpenClaw world, and there were a lot of things that were really cool about it, and a lot of things that I wasn't super jazzed about for my own use cases. And so that's why I did this. And I want to tell you, one of my favorite reasons that I love what Cody does is that this is all free. I didn't have to pay for inference at all with an asterisk. The asterisk is I don't have to pay more than the existing subscriptions that I already have. How many of you have more than one AI subscription? Like one place where, yeah, you have more than one? Why do you have more than one? You're laughing. Yes, of course I have more than one. I've got ChatGPT, and I've got Claude, and I've got, I don't even know, like so many others. And of course, you got your coding assistants and everything. So the reason that I can make Cody free is because I build on top of those. Everything that Cody is actually exposed through MCP. And that's what makes it so I can do all these cool things with Cody for free, because Cloudflare infrastructure is like hilariously cheap, especially if you're serving just one user. And so I'm effectively able to do all of these things using my existing subscriptions for all of the inference. So I want to tell you a little bit about how that works. And my goal here is to kind of like make you, a lot of people, actually, back up. How many of you thought MCP was dead? For real? Yeah, OK, no shame. How dare you? Just kidding. But a lot of developers, especially, are like, why do we need MCP? I have a CLI. I'm already signed into GitHub using my CLI. CLIs have help flags. There's like progressive disclosure. And like, in fact, models are even trained on some of the more popular CLIs that I use. So, and now we've got this skill thing. So even if the model's not trained, I can just use the skills. So what, like, who cares about MCP? And I agree with you. I think MCP is pretty uninteresting for software development use cases. Where it gets really interesting is when I tell Cody, I don't want the sun to glare in my eyes. So the non-developer use case is the thing that gets me most excited about MCP. So one of the big criticisms of MCP has always been that there's context bloat, and it's a huge mess, and so we hate MCP. Well, that never made sense to me because like we're software developers. We see a problem and we don't just say, huh, I guess this is foundationally flawed and go off to something else. No, we're like, you would analyze the problem. Is this foundationally flawed? Maybe. Let's look into it. Oh, we could just do some sort of search on the MCP tools and then boom. Now we have just the ones that are relevant for the thing we're doing. That's exactly what Claude does now. ChatGPT does this now. So the whole context bloat is not a big deal. However, I really like the fact that Cloudflare introduced this idea of code mode because it has unlocked a lot. How many of you have heard of code mode before? OK, so it's the idea that you can take some sort of spec like MCP or OpenAPI or something, turn it into TypeScript definitions, and then tell the agent, so this would be ChatGPT or VS Code or Cursor or Claude Code or whatever, tell the agent to write code against that TypeScript definition, and then on your side, you evaluate that code in a safe environment. And Cloudflare has done this with dynamic worker loaders. It's so, so cool, and that's what I'm using. So based off of what Cloudflare has done with their own MCP server, I created Cody to have 3 tools. They did 2. I needed 1 more. Search to identify what capabilities there are, so there's your progressive disclosure. Execute to write and run that code inside of those. Made me a little less interested because of all the cool things that Claude desktop is doing. Have you all seen this stuff? You're just like, build me a thing, and it builds the thing, and it's really, really awesome. I don't really use this one quite as much, but I do use some features off of that. So pretty much search and execute are the things I want to focus on. It is pretty cool to be able to open a generated UI. That's how I built the little game that my son played, and that was fun. All right, so somehow duplicated that slide. My bad. OK, so let's talk about search first. So when the search tool is called by your agent, whatever agent that be, it's going to pass a query, some sort of like, let's say that here, let's try this. We're going to actually try this. I hope that I don't regret this. OK. I'm standing up in front of hundreds of people in Miami at AI Engineer Miami, and I need some hype music. Could you play something on my Spotify, please? I'm already running it on my laptop. So you know how like when you're doing an AI demo, and you know the mistakes that the AI is going to make, and so you just kind of like subtly insert another little like, here's a little bit more context. OK, so first, here's the loading tools bit. That's Claude saying, I know that like we're not just going to load all the tools into context. So it loads the tools. It knows from that there's this execute tool. It conveniently missed the search tool, which is perfect for our demonstration here. I'm being sarcastic. Thanks a lot, Claude. Oh, that's interesting. Spoiler alert. We'll look at that here in a little bit. OK, I'm going to let this run in the background. And if we start hearing music in the background, then we'll know it worked. OK, so Spotify weather, current location playlist. So the query that we're actually exploring is, I want something that's thematically appropriate for Miami. So that's where lots of this is coming from. So we're going to query that. I want to limit the results to 10. And then here's what I'm trying to do. So this memory context thing, Cody has memory built in. And so this memory context will help to retrieve memories as appropriate. So then here are the search results. It has this whole explanation of how you actually deal with these matches. This only shows up on the first time you run the search query, and then thereafter it assumes that the agent is going to remember that, so we don't bloat the context. We'll look at some of that stuff here in a little bit. Ooh, secrets, what's that? We'll look at that later. And here's some relevant memories based on what you're trying to accomplish. And then these will also not show up in the future, so it keeps track of what memories have been shared. And then we've got this idea of packages. So inside of Cody, this is as of less than 24 hours ago, I made a complete, huge, massive rewrite. Let me correct myself. Cursor and GPT 5.4 made a complete, massive rewrite of how Cody works under the hood, and it uses Cloudflare's new artifacts API. Yeah, we're excited about artifacts. It's like, so now Cody has its own GitHub, basically, on top of artifacts. And it's cooler than that, but I want to show you the code for that here in a second, so I'm not going to spoil what else it can do. So it has a package for Spotify. This has secrets for interacting with Spotify that are created in such a way that the model doesn't actually have access to those, which I think is pretty cool. And I will use my 4 minutes to hopefully explain what that is. And then we also had we've got a value. Here's our client ID, and we also have secrets. And yeah, that's all that we need to see there. So it performs a search. Now it knows, oh, OK, I'm going to use this Spotify capability or this Spotify package to write my code. So now it's going to execute. Wonder how it's doing. Not so well. But it's trying, and that's more than you can say for ChatGPT. They're all improving. They'll be fine. So on that first search, it gets back a conversation ID, and then the agent uses that. And that's how it keeps track of the memories that have been shared over time. Here's the memory context. Here's what I'm trying to do now. And then here's the code that I want to execute. So what does that look like? This is an example of what that code might look like. So it brings in this Cody runtime that has some useful features for authenticated fetch, which conveniently or inconveniently for our demo doesn't allow me to show you how that authenticated fetch works. But basically, there's a special syntax that Cody can write code for managing secrets. So a really important part of all of this is that the agent, whatever agent you're using, never sees the secrets, ever. It cannot. And so the only way that you add those is the agent will give you a URL that will go to heycody.dev. You put in your secret in that UI on HTTPS, so nobody can see it. And then the agent can then reference it using curly braces in any fetch call. And then, because I'm using dynamic worker loaders, I can intercept every fetch call. And I look and I say, hey, that's a pretty cool secret. Let me make sure that you've approved that secret to go to this domain. Oh, that's like your Spotify token. I'm not going to send it to dangerousdomain.I'veBeenPromptInjected.com. Instead, I'm going to ask the user, hey, is this cool? And then you can go through an approval flow. That's pretty cool. So we also, this is pretty cool. We've got this environment lookups weather package. So this is where we can interact with all of our weather stuff. It's packaged up as a weather API. And this is under the Cody namespace. So this is kind of like our own internal NPM. And so we can have all these different repos inside of Cody on top of artifacts. And then when we're executing this code, we go and reach into the repo. We create a bundle out of that, export, and then we can use it inside of anything. So Cody can write code that references all of these things. It's super, super cool. And then, of course, all of this is what you would expect. We have an export default that can run authenticated stuff with Spotify. Here it's getting the weather, and then it does a query, and it does searches, and then it plays, but it reached its tool limit. So that's what I get for changing everything just before doing this demo. Just here, how about this? It worked! Just kidding. Just kidding. I promise it does work. I am still working on some of the kinks. OK, so then the return will have the conversation ID. Execute also returns relevant memories based on what was actually accomplished. In particular, this memory context is like, what are you trying to do? OK, I did the thing, but also here's some additional memories. And here's the results. And the agent gets to choose what results it gets back. So another criticism of MCP is that it's not just the tool descriptions, but it's also when we invoke the tool, the output of that tool fills up our context. The agent gets to choose what comes back from all of these executions. And like code mode is so cool. You don't get it. I can tell because you'd be like jumping on your chairs if you got it. Code mode is fantastic. If we tried to do the same thing using regular tool calls, this would be many regular tool calls, and it would probably mess up a lot. So code mode, agents are really, really good at this, and it's super cool to play around with. So I've got 29 seconds, which is wonderful because I don't have a lot more to share. Actually, I do. Come talk to me. I've got stickers, and I will give them to you if you ask me good questions. But yeah, come and talk to me, ask me questions. Epic AI Pro here's my little plug. That's where I'll teach you how to build MCP servers. And it's really, really great. Kodi is open source. It's pretty much just for me. I would love to make it possible for other people to use right now, or eventually. But yeah, Kodi right now is just kind of my thing. I mostly just wanted to show you that MCP rocks, code mode rocks, and we've got a lot of really cool and exciting things to look forward to. With that, go check out Epic product.engineer. It's the last skill you need to learn. Thank you. Good luck.
All right. I guess one thing that we can take away is the squats. So if you feel like you need a little bit of a wake-up call before the last two talks, feel free to stand up and do some squats. So I'm going to do it myself to get ready for Rita's talk. Yes. OK, so Rita is a really good person to befriend because if your website is down, she will be a great person to call because Rita is the VP of product for Cloudflare. And she has been building a couple of developer platforms and AI initiatives within Cloudflare. And she has meandered a little bit from a software engineer to solutions engineer, and now in product development. So Rita today will be talking about building infrastructure that can scale to billions or even trillions of agents. Take it away.
Thank you, thank you. Quite the intro. OK. We can build infrastructure for trillions of agents, but let's see if we can figure out how to plug this in correctly. You guys see stuff? OK, here we go. How about now? Aha! All right. Hello, everyone. My name is Rita. I am VP of Product for Cloudflare's developer platform. Kent already said everything that there is to say about code mode and MCP. So thank you, everyone, for coming. No, I'm really, really excited to be here today. Cloudflare is a really interesting place to be. Sometimes people ask me, you do product at an infrastructure company? How does that work? And it is actually really fascinating, first of all, because we get to work at really, really massive scale. So especially working on a developer platform and developer tools, every single optimization that we make, we instantly get to see the benefits of it. And even the tiniest things can really save everyone lots of hours, lots of days. But the other thing that's really interesting about it is actually the physicality of the web is something that I think people don't think about a lot. Like there are undersea cables, first of all, that connect us all, that when you have a Zoom with someone in London, that's how it all works. When I first joined Cloudflare, I came across an incident page that was talking about how it was like breaking record heat in India, and that was affecting a data center. And I just never really thought about how it could get so hot that a data center would go down. So I think that more and more, we are going to start to get connected between the real world and what's going on in tech and AI. And so I am going to talk about MCP in code mode, but I'm going to dive into some of the underlying details of how we do all that. Now, a lot of the time, our job feels a little bit like debating the age-old question of if a dog were to wear pants, would it wear them like this or like that? If you think it's the first one, raise your hand. If you think it's the second one, raise your hand. OK, everyone that raised their hand first, you're a psychopath. It's definitely the second one. Like, how would it put it on? No, thinking about how agents work, it is kind of similar. And you'll see this come up more and more, right? You can think about a single giant MCP server. You can break it up into a lot of smaller pieces. You can think about, should you execute the code here or over there? And for the first time, we're getting to not just do like micro optimizations in the developer space, but really truly invent stuff from the ground up and really think about it in that way. And so when LLMs first came around, when we started using them through ChatGPT about 2.5 years ago, it was like having a really, really smart brain with you in the room all the time that you could ask questions, you could get it to maybe generate code for you, but it couldn't go that extra step of doing too many things. It was like a brain with no hands to really act on its behalf. And that's because LLMs initially weren't that good at tool calling. But increasingly, they became better and better. So you could actually start to build agents like Qodo that could take actions on our behalf. And initially, when people started using tool calling, every single agent was implementing the whole thing soup to nuts on its own. So you had your tool, and you integrated it with your agent, and that was the only place where it could run. The really cool thing about MCP, and especially remote MCP, is that all of a sudden you could share tools with agents that you've never actually met before. So you could start to, you could create an app, you could ask it for the weather, but there's this thing that started to creep in over time, which is the context starts to grow. So I was going to demo a small app that I built called Fluma, which is fake Luma. I'll demo a different version of it in a bit just to save us on time. But if you're building something that's more sophisticated than something that I vibe coded in a weekend, you really start to see that scope creep, that token creep, right? So something like the Cloudflare SDK, it has all of the DNS records, it has all of the workers, it has R2, now it has purge cache. And before you know it, you're exceeding a context window of 1.7 million tokens. And actually, if you were to include Cloudflare's entire OpenAPI spec, it would take up 2.3 million tokens, okay? So that's more than the biggest models can even fit these days. So it's a bit of a pickle for us. So, okay, we started to think about how do we solve this problem. And one way to do that is we could split up the server by domains. So you could have an MCP server for just the API. You could have an MCP server for documentation. We had an MCP server for workers, for observability, all these different things. And that partially solves the problem, but it actually really just puts it on the user to figure out which MCP server they need. So if I want an MCP server that deploys my worker, but then to look at the logs, I have to go through the whole OAuth dance again. It's very, very annoying. So we needed to solve that. The second thing that we kind of realized the more we were thinking about this is that even though LLMs had gotten a lot better at tool calls, they still get confused pretty easily. Like if you ask it to do something that happened on a given date, it's just going to assume a random date that it was trained on in the past. It might not get the exact tool that it needs to call. If you give it a lot of different tools, it'll actually also get confused. Like a lot of tools have create in them, create worker, create DNS record, starts to do the wrong stuff. And if you think about it, it makes a lot of sense. LLMs were trained on like all of the code that exists in the world, so they're very, very good at writing code. But tool calling is something that we just kind of bolted on at the end. And it's not too dissimilar from if you took Shakespeare and you gave him a month-long crash course in Mandarin. I presume he was extremely, extremely smart. So then if you asked him to write a play in Mandarin, it's bloody Shakespeare, so it's going to be good. but it's not going to be his best work. And LLMs are a little bit in the same way, where no matter how good they get at tool calling, they just don't quite cut it. So at this point, we started thinking, OK, are we holding this wrong? Like, we're trying to make LLMs do things that they're not that good at. We're inflating the context window. What's a different way to attempt to do this? And that's where code mode came from. So imagine if you let the agent or the LLM do what it's really good at, which is write code, and do fewer tool calls. So let's see this in action. So here I have my app called Fluma. Let's increase the font on this. And on one side, we have our vanilla legacy MCP agent that's just going to make regular tool calls. And on the other hand, we have our code mode agent that's going to write code first and then execute it. So let's ask it to do something simple first, like create an event for a hackathon on Wednesday at 9 a.m. at Hyatt Regency, Miami. Oh, misspelled Miami. Miami. OK, so over here we have our regular MCP agent. It wanted me to confirm the date. It was thinking about January 10th, 2024, which is not quite this Wednesday. On the other hand, we have our code mode agent that just pulled up today's date because it's able to call a function. And then it used code mode to create an event that's going to come up. But now let's try something even more sophisticated. So I'm going to ask it to do something like create an event for each day in May 2026 for a meetup on the topics of AI engineering or MCP at Cloudflare's party house, all at 7 p.m. OK, so now they're both going to be off to the races. You can see that the MCP agent is going and making a whole bunch of different calls. And on the other side, we have our code mode agent that went ahead and generated this code with different topics. And it's going to go through this for loop and create a whole bunch of these events. So now it's making a bunch of calls to the API. Going to wait for both of these to finish up. Any second now, guys. All right, so our MCP agent is already done. Generally, these take about the same amount of time. Now, our code mode agent is also done. So we've accomplished roughly the same task. But notice one important difference, which is the code mode agent used almost 70% fewer tokens. That's a really, really big difference because the code mode agent doesn't have to carry all of those tool calls in its context constantly. It's able to just generate the code once, execute it, and be done. All right, but we had another problem. And it's that clients were slow to adopt code mode. And if you want something done, my parents are Soviet, so they would always say, you have to do it yourself. So we had to take matters into our own hands. We still had a context window that would take up over 2 million tokens. So we started thinking about what would it look like to have a server-side MCP server. And we came up with a way that allowed us to still run all the code that was generated on the server side with two simple functions. One that's called search, which is going to look at the spec and just find the and only find the APIs that match the particular type that we're looking for. And another one that would write the code that would actually execute what we needed it to do. So let's take a deeper look at how this works, again, under the hood. So we, first of all, have our tool search. I'm going to type workers in here. And even if I added like every single workers API that we need, we're still only, I don't know if you guys can see this, less than 2,000 tokens. So a very, very big difference from 1 million tokens. And then we have the second half of this, which is the execute tool. So here, what the execute tool is going to do, it's going to look at the TypeScript schema that's being passed down from the search tool. And it's going to generate this code that it's then going to have to execute. So here we have list workers. It's going to write code to list all of our workers. You can write code to deploy your worker, add access on top of your application. And here we can quickly see this in action where this code was executed. And here is the result that we got. So OK, now let's put the two of these together and ask our MCP server to create a hello world worker. So the first thing that we're going to do, as we would with any other MCP servers, we're going to go through OAuth. And select the account that we need. This is where I'll deploy all of my workers to. We authorize it. And now it's going to call our two commands. So first, as you can see, we're running search in here. And it's, as predicted, going to return all of the different worker-related APIs that are available to it. And then we're going to run execute, which is going to generate this worker. And we are going to execute it immediately. So now we have a hello world worker that's been fully deployed. So we talked about 3 different models basically so far of doing the exact same thing. One that's basically vanilla MCP, where you're directly doing the tool calling. That's going to be the least efficient in terms of token usage. We talked about client-side code mode, which is efficient, but not all clients support code mode yet. And another one that's server-side code mode, where if you think about, we saw the results where it went to 70% token savings. But if you go from 2 million to like 2,000, it's like 99.99% token savings, which if anyone here is paying for tokens, you know that that's a lot of money that's being saved. But how does all of this work? Like really what we're doing is we're putting a lot of trust in the LLM to write some code that we've never looked at before and allowing it to execute immediately. And this can bring a lot of problems, right? If you're running it in the same sandbox as the rest of your application in the same container, it can do things like read the file system. It can make rogue network requests with the data that you just gave it. It can do things like create an infinite loop or eat up all of your memory. And there are a couple of ideas of maybe things, other approaches that people have tried. One is DSL. If you've written DSL before, you probably never want to do that ever again in your life. Another one is you could use VMs, but VMs are very slow to start up. So we would be waiting here for a very, very long time for all of these calls to complete. And it would get really, really expensive very quickly. We could get humans to review the code, but that's even slower than VMs. So we need a different approach. And this is where dynamic workers come in. So dynamic workers are based on the same technology as workers, which we've been running at Cloudflare for over 9 years now. But dynamic workers allow you to create a worker on the fly and immediately execute it. So you can see that here we're going to pull in the generated code that the LLM created. The rest of this looks just like loading up a worker. You can set the compatibility date and which modules you want. And importantly, you can set what outbound hosts you want to allow. And so if you don't provide any, the worker actually can't access the web at all. So everything stays really, really sandboxed. And we can actually test this out in practice. So as far as being worried about things like configuration keys or other things being leaked, it's only going to have access to the things that you gave it explicit access to. So if I'm trying to access secrets in process.env, well, guess what? It's not going to show up in any of my globals. These are just the functions that Cloudflare provides by default. And if I try to make an outbound fetch to HTTP bin, well, the same thing is going to happen. It's going to say this worker is not permitted to access the internet. We should really capitalize this. Yeah, you can't just access all of these arbitrary things. So it becomes a really, really powerful environment to enable you to run code mode securely. And so far, we've just talked about this in the context of MCP. But I think it's pretty obvious where agents are going next. And it's that all of us are going to be running many of them at all times. Right now, I would imagine all of us are using agents like OpenCode or Claude Code, Codex, primarily for coding use cases, right? And a lot of them run on our laptops, which is why people at this conference are running around not wanting to shut their laptops, right? Because you want your agent to complete your task. And you could do this also in a hosted container environment. But if you start to do the math of how it's going to scale to the rest of the world, and we'll get to that in a second, the math doesn't quite math. And here's what I mean by that. So recently, OpenClaw has been taking off, right? And it's kind of a similar thing where it's early adopters, and all of us went and got Mac Minis. But again, that's not sustainable for every single person being able to run multiple agents. And if you do the quick math just on the US alone, and just for the workforce, right? There are about 100 million people in the US workforce. If we set 50% concurrency, so this is actually being very conservative. I actually imagine that we'll be running a lot more agents than this at all times, because guess what? Agents don't even sleep. And by the way, I have an Agents Never Sleep hat that if you're the first to the Cloudflare booth, you can claim. But we're going to be running many, many of them. And for that, we need a lot of CPUs to power that. Everyone is talking about the need for GPUs, but no one is talking about this part of having to power enough global agents. So let's take this a step further. OK, there are 8 billion people in this world. If each of them had a personal agent, again, at like 50% concurrency, we're not super coordinated in how we're using them. We need like 80 to 160 million CPUs. Server CPU production today is in the tens of millions per year, so we're already an order of magnitude off. If you start imagining that everyone is running several agents, 3 agents, 10 agents, we are many, many, many orders of magnitude off from being able to power the agentic future that I think everyone in this room is really excited about. So how do we solve this problem? Believe it or not, yet again, dynamic workers. So the thing about dynamic workers is they run on isolates. And isolates are a lot more efficient than VMs or containers because they're able to share so much more of the underlying context. So in a VM, for every single new application that you spin up, you share the hardware, but you have to spin up a new operating system every single time. For container, you're able to take that one notch further where the operating system is shared, but every single time you spin up a container, you need to bring in the entire language runtime and the full application with it. With isolates, we're able to import just that generated code, whether it's the application or the agent-generated code, and execute it on the spot, which means we can utilize the same exact hardware, but 100 times more efficiently. That basically makes up the difference that we need in order for every single person in the world to be able to run their own Cody agent. So this is why I'm so excited about isolates. And what's really cool is we've been working on this for a long time. We bet on this technology 9 years ago, and we didn't think that it would become relevant in this particular way after all this time. And it's interesting to see more and more companies, Cloudflare is not the only implementation of isolates, and I think the more people use it, the more people adopt it, the more validation it gives what Cloudflare is doing. And we're still going to need containers for some agents because you need Git and Bash and file system and all of that. But for especially consumer use cases, isolates are increasingly going to matter more and more. So that was a lot of me talking. If you want to learn more about this, there's a whole bunch of blog posts that we put out, especially last week, that I recommend you go check out. Dynamic workers are an open beta, so you can go and play around with them literally today. I will also give a couple other shout outs to experiment with everything that we talked about today, including code mode. You can go install Cloudflare's Agents SDK. We just made Kimi 2.6 available on Workers AI. It's a brand new model. It's super fast. Go play around with it. And last but not least, we have a lot of really hard problems to solve, and we need help solving them. So we're hiring, and if you're looking for your next gig, come find us. All right, thank you all so much.
Okay, how's everybody doing? We're almost there, last talk of the day. And speaking of SDKs, the next presenter believes you're using the wrong AI SDK. And he's going to talk about the evolution of SDKs for AI and where we should expect it to head in the near future. He is an educator, a full stack educator, from developers to all the way up to tech CEOs and CTOs. He has a podcast, and he also manages Theo's YouTube channel for technical development. Please welcome Ben Davis.
Perfect. All right, so the title of this talk is You Are Using the Wrong AI SDK. And before we even get into that, I want to kind of talk about how these things have changed over the last few years. Because when I was going through and prepping this talk, the initial concept for it was, all right, I want to take the OpenCode SDK, the Pi SDK, the Vercel AI SDK, and then the BAML SDK, kind of compare those four and kind of explain when you would use each one. But as I was going through, I kind of realized that there's a pretty strong through line here. I've kind of, at least in my head, I like to think of these in generations, where the first generation, we had the API wrapper. This would just be the normal OpenAI SDK. You can see the code snippet for it. Let me zoom in. There we go. It would look something like this. You're just directly hitting the OpenAI API to generate some text, maybe do a tool call or something like that, but there's nothing else built into it. I assume if you're here, you probably know what an agent loop is, but in case you're not familiar, generally speaking, the way these things work is if you want it to do some more complicated action than just generating text, like reading a specific file or doing a web search, the model can't do that on its own. It has to ask you to do that for it. So what it'll do is when you send a request up to OpenAI, it'll send back a response that instead of being a text response will be a tool call response that has the input, the tool that it wants you to call with some arguments, and then you go ahead and call that tool and send it back. You can do that full tool calling loop within the normal OpenAI SDK, but it requires you to manually have a while loop and add a bunch of other stuff in here to actually make that work. It's not the most ergonomic thing in the world, which is why the Gen 2 that came along was the Vercel AI SDK. I think this is one of the coolest things Vercel has made in the last couple years. Like, this is truly an incredible open source project. It seems very simple, like it is just wrapping a bunch of different LLM API providers. But the actual layer for having the actual code that goes into making a centralized interface that goes around, that can both Anthropic models, OpenAI models, Gemini models all in one place is pretty insane. And the actual code for this is a lot more abstracted now, where you can define tools with SOD schemas, you can execute them, it has this stop when, which means that now that agent loop can happen within the actual SDK. This generate text call will hit the OpenAI API multiple times here. So if I go in and I zoom into this, if I do bun2 for the second generation, as this is actually running, it did multiple requests up to OpenAI to do that weather tool call. And then when it did that tool call, it went back again, passed that result back in, it generated the final text, and then that's what you saw pop out on the screen. So this was enough for people to start actually building agents with. This was the sort of first generation where we were really able to push these things into making more complicated and useful products. But there were a lot of decisions and beliefs that were made at this time that I don't think have quite held up. And these are a lot of things that you had asked me 4 months ago, I would have personally believed. Where, like, if you look at the code for the AI SDK, one of the things you'll notice is that there is full type safety on the tool calls. Like this execute takes in a city. You can see that it's a string. It has this input schema, which is a Zod validator, so that it makes sure it's always going in the right shape. It is very much built to allow you to make these very well-defined agents for your products. But that is not where we have kind of ended up. Because the thing that happened sometime last year was Claude Code got released. And when Claude Code got released, we got the first full coding agent, which was effectively something like the AI SDK wrapped up with a really nice TUI that can now suddenly take actions on your computer with an exec tool call. It can run bash commands, it can run scripts, it can write code, it can do whatever the hell you want it to. And over the last year, we've had more and more of these pop up. And the two that I wanted to talk about specifically in this presentation, because I think they're just like, they're the most interesting ones to talk about because I think they're the best ones to use. I'm not personally a huge fan of the Claude Agents SDK for a variety of reasons. And the Codex SDK is limited to Codex, but these two are both open source. They're incredibly powerful, and they are the things that power the actual coding agents. And when you're working with a coding agent SDK, you are able to do so much more than you can do with these things because the mental model has changed a lot. I'll start with the Pi example because it is the more minimal version of these two. If you look in here, the way this actually is defined is kind of similar to the actual AI SDK thing, where we are defining a weather tool here with some basic stuff we have, as you would expect. Then we are creating an agent session with the model, the auth storage, the model registry, custom tools. These are all implementation details. If you want to look into how to actually use these things, the best thing you can do is just like go to the GitHub repo, copy paste the link into whatever coding agent you prefer, tell it to make a temp directory, clone the repo into that, and then ask it questions. That is the easiest way to figure out how to actually use these things. But the real point that I'm trying to make here is when we create this agent session, even with the TypeScript SDK, it is booting up the full agent harness. Because if I do Pi, this is now a full coding agent that is running on my machine. You can ask it, it works the way you'd expect. Same thing is happening when I am doing this Pi example here. So if I go into the agents.md, always answer in French. So if I go in here and I run this example again, bun3 Pi, I think I called it. I think this is the version that should be loading the agents MD. Yep, it's doing its tool calls, getting all that, sending it back, and there you go. So you can see, even though I didn't have any code in here that implicitly loaded the agents.md file, it still did because it is operating as a normal coding agent SDK on my machine, does its thing, gives me the result, very, very useful. OpenCode is very similar, except I would say it does the same thing, but is more batteries included. I love both of these projects. I think they're really cool. I mean this is a very high compliment to both of them. But the way I kind of think of them in my head is that OpenCode is kind of like the VS Code of coding agents. It is open source. It has really good defaults. It just kind of works out of the box, but you can still change some things about it, add in different themes, extend it, do other stuff there. Versus Pi is kind of like NeoVim, where right out of the box, it does basically nothing but the absolute border, like the true essentials for a coding agent, but you can extend the ever-living hell out of it. And it's really cool. I like both of these a lot. But you can see this reflected a lot within the SDKs too, where the OpenCode SDK works slightly differently, where you can where the way it actually works is it is a client-server model where whenever you spin up OpenCode, it's spinning up a server. So we have to create our OpenCode instance here, which has the server. Then we can do a bunch of stuff in here to create a client session, subscribe to the events, console.log them. Nothing too interesting there. The only really interesting piece here is that there is this .opencode directory with a bunch of custom tools in it. This is how you define custom tools. Again, don't pay too much attention to the syntax here. That is not the important piece. I'm sure that this will be changed and improved over time. It's solid right now. It's not the important part. The important part is the way we can actually build with these things now. Because like I said, with Generation 2, we were entirely focused on these very well-curated agents. There was the type safety on the SDK, really trying to be like, okay, let's give it a dedicated read tool, a write tool. Maybe if we're doing something, say, for my own personal use cases, it needs to hit the YouTube API to do some stuff there. We would give it a read YouTube API tool, give it a, we would give it a read YouTube channel tool, a read video tool, a read comments tool, whatever you want to do. All of those are well put together. Then you give the agent, you let it execute, you do that whole thing. It's fine, but do things kind of differently. And Okay, I was going back and forth on this, but I think we're going to do it. I'm going to pull up, oh my God, I cannot see. Can we see that? Yeah. So just hear me out, hear me out. Okay. Again, hear me out. So there's this project called GStack, and you've probably seen it on Twitter because it's been memed very heavily because Gary has been going very hard with these LLMs, and there have been a lot of memes that have come out of this. The 40K lines of code in a day thing, the crazy Gary's List site, which is hundreds of thousands of lines of vibe-coded Ruby for a static blog site. There are some silly things in here. I'm not denying that. But there's also some very, very good stuff in here, because when I looked at this about a week and a half ago, I went into it fully expecting to just kind of see something funny, maybe dunk on it, do whatever, because that's what everyone else was doing. I was like, yeah, sure, let's go take a look. And I went into it. I went into the skills directory, which I think is right here. Let's use the, that's a good example. Let's do the office hours one, sure. I went into this, I looked at the skill, and the first thing I saw is this 30-line bash script that looks like a virus. This does not look like something I want to have in my skills. I was like, what the actual hell is this? What are we doing here? This is worse than I thought. I was going through this, and I kept reading, and then I just kept going through all this. But then as I slowly just kind of started to think about it more, I realized what I was actually looking at here is a program. And I know that sounds very insane, but if you think about what this actually is, it is including a bunch of commands that the agent is supposed to run. It has a bunch of steps. It is defining a workflow, and it is creating a full usable application entirely on top of a coding agent with natural language. And the more I thought about that, the more I realized, holy shit, I think Gary is onto something here. And I've been testing it more, I've been going deeper into it, and I've realized that with these Gen 3 SDKs, these full coding agents, we can do some very weird stuff that we couldn't do before. Before with Gen 2, we were still having to manually write TypeScript functions for every single piece of the agent. But now in Gen 3, we are using coding agents, and coding agents are capable of writing code. They are capable of executing bash scripts, so the actual programs we're creating with these agents do not have to follow the patterns that we previously had. I was sitting up in my hotel room earlier today, doing a little bit of experimenting here, and one of the things I put together here is a better BYTS sync. And effectively what this does is this is a little program. I don't want to save that. This is a little program which allows me to go to the YouTube API, sync all of that data down into whatever place, and then save it into a PG-Lite database. This is a very, very useful thing for my job day to day. I need to have this data. I need a way to sync it. And the way I've done this in the past is by writing out a pretty big, complicated TypeScript project, which will do the manual syncing logic. Like, obviously, it seems very simple. Like, you're just going from one API to fetch 2 DB. But what about retrying? What about the actual orchestration of this? What about the cron job? And then there's even more things like, OK, so what if we want to do some deeper parsing on the videos? What if we wanted to parse the sponsor of a video, because that's very useful information for us to have, or parse the sentiment on comments? Well, now we have to bring in an LLM. And the way I was bringing in an LLM is with one of the things I was talking about earlier, which is BAML. I think BAML is very, very cool. Currently, it is entirely a Gen 1 AI SDK. I am sure that they are working on something new to do the actual agent thing. But for right now, effectively what this is it is a new programming language designed for agents that works really, really well for taking some blob of text or data or videos or whatever you want to do, giving it an output shape. So I'm like, OK, this is the actual output shape I want to get from BAML. This is the function that we are doing here, which takes in a video. Video is a data type, which just take in a URL so that it knows it's a YouTube video. Video sponsor is a list of these. We pass in the prompt here. We have this. And you can see within their playground, what I did is I passed this in to the Gemini API. People did the actual orchestration of this. They have a lot of stuff under the hood that ensures that the LLM will output in the correct shape, and you get the correct shape every single time. Because obviously, when you're working with little non-determinism machines, they will do non-deterministic things. And even if it's a 99% success rate, this does a great job of getting you over that line to make sure that it will always be in this correct shape that you can then pass into your TypeScript code and do something useful with. You can see, like, for this video, it was sponsored by G2I, just like this conference. We love G2I. And the thing is, that's great. That all works just fine. But it gets kind of annoying. And what if we did this differently? What if instead of writing the program as a bunch of TypeScript files, what if you just wrote it as a bunch of Markdown files? And that's what I'm trying out here. And you can see I have a couple different skills in here. There's nothing too crazy about these. The most interesting one here, I guess probably, well, I guess we can go through all three briefly. So the top level one is this YouTube videos sync skill. And this basically just tells the agent the steps it needs to go through to sync the YouTube channel. It has a bunch of like helper functions in here so that like instead of manually writing some Python code to fetch the API and then put it in the DB, it has these good like wrappers, so like fetch channel, it does all of this correctly. But you don't even need this. In the first version of this, literally all I had was just a Markdown file with some natural language steps, and I'm like, okay, go sync some data from the YouTube API, here's an API key, put that in a Postgres DB, good luck, and it did it. It did it very, very well. This is the reason why something like OpenClock can work so well, is because these coding agents can just kind of make these things happen. The only reason I have these extra functions in here is because I intend to deploy this and use this elsewhere, and I want it to be a little more robust. But you can see all we're really doing here is defining the steps, which is what you would do in a normal program, and then let it run, and it will do the thing. And it has a remarkably high success rate. You end up kind of getting this nice property on these things where it's kind of almost self-healing, where I noticed a couple of times there would be like a weird rate limit error or something like that. Instead of having to do exponential retries yourself, the agent will just kind of naturally do it for you. And now the way all of this kind of comes together is if you are building something like this and you are building it with skills and you have all these extra things in here, if you want to run this with an SDK, because one way you can do it is I could just open up Pi here and I could just do /sync. I hit enter on this. It's just going to start doing the syncing. So it's checking the project directory, CDing around, doing whatever it needs to. But if we don't want to do that, say we want to run this on a sandbox in the cloud on a cron job, you can use the OpenCode SDK, which is what I'm doing here, to create an OpenCode instance, create a new session, then pass in a prompt that tells it to use the skill to actually do the thing, log some useful information up here, and then it works. Because like I said earlier, since this is a full coding agent SDK, it is reading all of the skills out of that directory. It is reading all of the agents MD. It's even reading the auth stuff. So because my OpenCode is authenticated with GPT 5.4 Mini, if I ran the sync command with this index.ts, it would do that sync with 5.4 Mini. It all just kind of comes together and allows you to build these very weird new shapes of programs that I honestly didn't think were going to be a thing, but clearly are. And really that's what I wanted to get across with this talk, is not any specific implementation details. Go experiment with those on your own. The thing that I wanted to get across here, and it's really just a message for myself because I keep doing this, is that the shape and direction of where these things are going is very strange. It is changing all the time. If you had told me 3 months ago that I would be giving a talk where I defended GStack and Markdown files as a new way to do programming, I would have laughed at you, but here we are. Because the thing about this weird AI revolution right now is every single time I learn something new about it, or I find something, test a new model, try a new theory or whatever, I make a new line in my head of like, okay, this is what it is capable of, this is what we can do, this is how this works, and then that is like the box I live in, and I don't really go past that. But that doesn't work anymore. These things change so much, so fast, and you just need to try weird random ideas. Every time you have some very strange idea and you're like, oh yeah, that probably won't work, still just give it a shot because it might. On paper, this doesn't seem to work, and yet it kind of does, and it works really, really well. And you can even take like what's here and what is the next logical step here. Do I need to have all of this code written here? Can we go further with this? I don't know. All I know is that as time has gone on, we have started giving agents more freedom, and time will tell what that freedom will bring. So that's all I got. Thanks for listening.
All right, that was a great talk by Ben.
All right, awesome.
Okay.
Very, very big day with a lot of great talks, and we covered a lot of ground, I think.
What did we cover today?
We went from context engineering, some philosophical discussions, a lot of practical discussions, SDKs, MCP servers, and yeah, here we are. I think I need a drink.
Oh, okay, Iman. So are you more of a mojito person or a no-hito person?
We'll see. The night is young.
Okay. Let's see from our audience who is for mojitos. Nice. We see some hands. What about no-hitos? Neither? Okay, maybe you want
mojitos,
your Miami Vice. No judgments here. But what is happening here is that we're going to close out the day. I think you all deserve some good dinners, some good drinks. And we have a whole day tomorrow from 9 to 5:30 again. So we're going to hear from the organizer, G2I, all the way to some software engineer from Cursor. So gear up for another day of fully packed schedule, great connections, and great knowledge sharing. So that is it for today. Thank you so much for being here and joining us, and we'll see you tomorrow. Take care.